Hi. Hello, hello. Good afternoon. Good afternoon. Sure. Hey. So, let me know if you can hear me. Okay. Well, let me get started. Good afternoon. Thank you for coming. Right, so this is 138th episode, and today I am going to try to create a setup to create a so-called Venus Flytrap plant on Houdini. How by trying to simulate how it grows up as a plant procedurally using Houdini. So there is one reference I used to create this setup, which is on the same YouTube platform, and the video from Elapse. It has a bunch of plan time lapses, the growth time lapses, and there's one for the Venus flytrap, which shows how it grows from day 1 to day 60 or something, and which shows how interesting it grows up. Each leaf or flower has its plant like this, and you have this tip, which is going to be the place where you're going to eat the flies, so-called trap part. And all the other plants starting to grow. And there is one thing I can notice is that there's some folding structures to this plant. So it has its folding around here on the tip. It also folds these leaves as well, and this fly trap part as well. So I found this structure is interesting, so I wanted to recreate this folding structures of this plant, how it being bended and when it's on the baby and grows up by unfolding its structures, making its plant bigger. In the end, you have a trap on a tip. Yeah, so this is what I wanted to have as a final result, and here's the test that I did, which has its growth and unfolding structures. So would like to create this kind of a basic setup for unfolding plant together with the growth for each plant. And I'm going to use KineFX on Houdini to achieve that goal. Okay, so let's try to do this from scratch. Before I'm going to create the plant, I'm going to show the process that I'm going to take. First thing first, I am going to create a base bone structures of this plant, which in the end you have a bone in two parts, one from the ground to the neck of the plant, and from the neck to the tip, and this part will be used as the Flytrap part, and this will be used as a the body part. Okay, so first thing first, I'm going to create these bones and try to move them using KineFX. Try to make them grow, maybe starting from something like this, and then slowly unfolding like that. Make it bigger, make each part bigger, and unfolding at the same time. Then after having these bone structures, you could apply the geometry that you want to use it for the final result. You could just model some body-like shape here on the plan and some Flytrap shape here. And in terms of, you also need to have an unfolding or folding structures horizontally to these part as well. So maybe I would need another KineFX structures here as well. I might do that using KineFX, or I might going to do in some other ways, maybe in this case, because it's just a one axis rotation. It could be just a simple rotation instead of using KineFX, the complex KineFX structures, but I'll see it. Okay, so let's see. Let's start by creating the bone structures. First thing first. Okay, I'm gonna start by creating a straight line. First thing first, I'm going to create a geometry node and a SOP. Create a line. Okay, so this will be, I'm going to use this line as the base, the body part of the plant. And I'm also going to create another line on top of it, which is going to be used as the Flytrap, the head part of the plant. Okay, so let's do that by using copy 2 points. And I'm going to connect this line to the second input of this copied line. I'm going to target the point to the second point, so that another line that I'm going to create now will be copied on top of the body part line. Okay, so I have this line on the bottom, which is on the left, and I have this line on the right hand, which is I have this line which is on the top of this line. Okay, and maybe I should change the aspect ratio or the size of this head part to set up the proportion. So let's see if I can find a picture of this Flytrap to define the size of the body and the head. Well, such as this one, I can see could be like 2 to 4, 2 to 1, 2 by 1 maybe, or 3 by 2. No, 3 by 1. I'll say 2 by 1 for now. Maybe it will be better if I can change aspect ratio later. So I'm going to create a controller node. So that I can change this aspect ratio between the body and the head. Okay, and let's have this as 0.333 for now, which I'm going to use this as the scale for the second line, which is going to be used as the head. So I'm going to copy this one and paste it right here. No, not to this one, but to the lengths. So 1 by 0.3, okay, which is around like 1 by 3. 1 by 3, okay, as a ratio. Okay, so now that I have these two curves, I'm going to merge them. Hi Alan. I think using KineFX for the full animation can be nice since it allows to be exported to game engines and other DCCs. I see. Then let's try doing that, shall we? Okay, so I have just merged it. And next thing I'm gonna do is to resample this so that I have enough points to be able to deform the geometry, so so that I can make a curved geometry. I'm going to make a resample node. Can you do a tutorial series for VOPs? Well, I haven't used VOP at all myself, so not sure how to use it actually. I don't even know how to use the loop on VOPs, so maybe I'm not a good person to teach VOPs myself. How about Python? Yeah, I can do some Python. I'm not really fluent on Python, but yes, I can do the basics if anybody's interested. So I have in Python, I have a resample node, and let's see if I need to change these steps. Wow, currently I have 0.0, 0.1, maybe that's fine, but maybe it's better if I can change it as well. So let's have this resolutions for the resample to be parameterized. How do I call this? Bone res. Are you a Houdini artist or programmer? I guess I can call myself programmer more than an artist. I mean, I'm not really an artist, I'm just using this for fun. And I do use this for my project, but mostly as a programmer to create a setup for the artists, I guess. Okay, I'm gonna set this to 0.05 for now. Maybe I can come back later to change this value. Now, let's see. Now that I have two curves resampled, one on top, one on the bottom, and currently because it's just being merged, these points I have duplicate points right here on the connection, so I want to fuse it so that you have only 1 point on the connection. If you don't mind, how long have you been using Houdini for? 7, 8 years, maybe. Yeah, I think it's around 7 to 8 years. And next thing that I like to do is to have a little bit of a small attributes to each point, which tells you in which height each point is right now, which also tells you the length from the starting point. So the height information of point 1, point 2, point 3 will tell you the distance from the starting point as well, because it's just a straight line going to the y direction. So, and which is pretty useful later when you're going to bend this geometry with specific angle. So let's have that information. So I'm going to create a attribute called length just by copying the y attribute of this point, which will give you the actual height of its point, which also means distance from the origin, from the point 0, 0, 0, which is pretty useful. We'll see that later. Okay, now let's convert this into a bone by convert it into a KineFX available bone structures using rig doctor. Okay, and I'm going to check the initialize transform, which will create these local transform attributes, which will enable us to control this through rig attribute wrangle. Use it as a KineFX model. Okay. And everything else, I'm just gonna leave it as it is. It might be better if I have name each one. I mean, one for the top and one for the bottom. But for now, let's just leave it as it. Let's just leave it as it is. Okay. One thing I might want to do is to set a ID for the body part and the head part. Could be just an integer, could be a string, but to identify which one's which, it might be better if I have some attributes for that. So I'm going to create an attribute create to each of the line and make a primitive attribute called part, and I'm gonna call the body part, just gonna use the integer and set it to 0. The second one, same integer part, and set it to 1. So if the primitive is equal to 1, it's head. If the primitive is equal to 0, it's body part. Okay. Now let's go to the rigging part. I'm going to use a rig attribute wrangle. Okay, and try to deform this curve based on a specific angles and time step maybe. Because I would like to make it as an animation as well. So let's do that. Okay, so to use the rig attribute angle, what you need to do is to access this specific attribute called local transform right here. You can directly rotate these transform matrix inside this rig transform, which will locally transform each point based on the process that I write here. So let's try this up. I can say rotate access to this transform, local transform. Let's say I want to rotate this by 3 degrees for each point, using x-axis for the rotational axis. So I'm going to first create a rotational axis, which is 1, 0, 0, which is an x-axis, and rotate this transform using some angle. Let's just use 3 or 4 for now. Oops. Then use this axis. See what happens. So what happened is it rotated each point by 4. So in the second point, locally it just rotates 4 degrees, but since you already have 4 degrees on the first points, in total it looks like it's being bended for 8 degrees, and third one to be 12 degrees and so on. So in order to use this angle or rotation value correctly, you need to think how many points you have in order to specify this the total rotated angle. Let's say I want this whole I want the whole angle for this plant to be like 90 degrees rotated. And if I just do that right here, it will be a problem because each point just rotates 90 degrees, but I want to have the total angle to be 90 degrees. So each angle must be the total angle divided by the number of whole points. So by doing this, you have 90 degrees rotations even if you change the number of points, which I can control it right here. Maybe I should change the range of this resolutions from 0.001 to 0.1. Okay, so you see that even though I changed the resolutions, number of points, the total angle don't change. Okay, so that's one setup you need. Now, another thing you want to do is to think about the head angle. Okay, this is the total angle for the plant, but actually I have the body part and the head part, and I want these to be grow like differently, like bend differently throughout the growth. So I need to set some conditions between this part and this part. Okay, so that's what I need to do. So let's try to do that. Okay, so in order to set a angle for the body part and the head part, I think I would need a number of points for the body part and number of points for the head part in order to define the angle for each part. So let's try to think how we can get those informations. So the rig attribute wrangle runs over the points, looks at each point, which means you can use point related functions such as point prims function using ptnum, which will give you a associate primitive number for each point, and get the first one, and then from this primitive number you can get a total number of points on each primitive by accessing to prim points, the points on primitive, which you can get it as a length of the arrays like that. Okay. Now if you want to have a 90 degrees angle for the body and also the 90 degrees angle for the head. In this case, you can use the same angle right here. You can change this by rotation angle divided by the length of the point of each primitive. And now it will give you something that looks different. So the first body will be rotated in total 90 degrees, and then the head part also rotated in total 90 degrees. Now, if you go back to how the plant grows up initially, it's kind of folded up initially, something like this. Yeah, something like really, really tiny. Maybe I might need to change the aspect ratio dynamically as well. But let's assume that we have same aspect ratio over time, and let's say we want to start the angle somewhere from here for the head. Okay. In this case, the angle which goes on which is rotating counterclockwise might not be right. So for the head part, I might want to rotate in the other direction, which in this case, this value will be negative, I think. So let's see how we can do that. In that case, maybe I need to change the angle itself, so I can make a conditions here. So in this case, we want to know which part are we looking at. Are we looking at the body, or are we looking at the head? So we need that information, which is inside the primitive attribute. So we can get that by accessing to the part attribute on primitive, which we created right here. Alright, so if part is equal to 0, which means it's body, maybe I can just rotate as it is. Now head part is not happening anything because I haven't made the conditions for that yet. Else the head, I can do the rotation with the negative angle and see what happens. Okay, something happened, but maybe the first angle, the tip, the first point of this primitive could rotate more drastically than this. It's just rotating a few in the initial point angle if you just use this, but maybe for the first point on the where the connection is to the head and the part, you might want to rotate more drastically. So I might also need another conditions for that, and that can be determined by let's say, well, the thing is, I am getting the primitive number here, but there is a chance that you get two primitives when you use these functions, which is where the point is at the connection. Okay, so maybe we would need to get that conditions here. So if int prims will be this value here. Okay, and you could get additional information if it's on the connection or not. So in connection is equal to length of prims in more than one. If it's more than one, meaning 2, which means it's on the connection point. So in that case, you could use another angle for that. So if the connection is equal to 1, meaning if it's true. This determines if it's true or not. Then you can give a negative but more drastic value for that. Maybe something like 90 degrees as it is. There you go. Now you're getting 90 degrees rotation just on the corner, just on the connection. Maybe it could be more, like 150, 140. Yeah, something like that. Okay, now you have those conditions. I can now set some procedural values for these rotations throughout the time, so that I can create some morphing or bending animation. Okay, I think it's better doing one by one, starting from body, then get to the head. Okay, so let's start by creating some animations for the body first. Okay, let's not think about the randomness yet. I can just introduce that later. That'll be easier to think without some random values. So let's do that without the randomness for now. I can all do the animation right here on the rig attribute wrangle. Let's call this bend animation. Okay, so first thing first, if you want to create a animation, you want to get the frame based value. So let's get that. It's called F, getting the frame. And there are several transformations you want to do in terms of growth. One is the scale, one is the rotation. Maybe you don't need a translation, but at least scale and rotation will be necessary. I'll start by just doing the rotation here, meaning the bending. Okay. So I need to define from which frame to which frame will be used for the bending for the body. So let's create that value first. Start body. Let's have some attributes for those. And could be an integer. So this, I would like to have the frame informations from which frame to which frame it's going to be used to grow to bend the body part. Okay, hello Alonso, if you don't mind, is this using group? Isn't group supposed to be group name 100? Currently I am not using group information for this one. Yeah, I'm just using those attributes inside the primitive and points, since I haven't set any group. Yeah, setting group might be better for these part. I just didn't do that for no reason. Okay, body. So let's have these two parameters. One will be used to define when the bending of the body starts. I can just say 1 for this. Start from the initial frame. Then let's say stop at 60 frame. Okay, now what I would like to do next is to remap this F so that it will be normalized in between 0 to 1 based on these information. Start body to the E body. If the frame is in the S body information, the value, then I want to make it to 0. I want to make the F to 0. If the frame value is in the A body value, which is currently 60, then I want to make the F value to be 1. So I'm gonna call this SF or F body. And let's create the normalized value by using a fit function, which if it is in between S body to E body, map it to 0 to 1 so that will be normalized. Okay, now that I have the value in between 0 to 1 linearly changing, I can remap this value to the angle for the body, which in this case is used right here. Let's rename this as well to angle body. And in the end, I might want to make it as 90 degrees in this case. So 90 multiplied by F body. Okay. And I also need to rename these as well. I'm also changing the head right now, but might want to change it later. Okay, so initially it's just standing straight. And if you increase time, just goes to the target angle. And let's see if that is correct. Actually, it starts from like 45 degrees, somewhere around 45 degrees, and lay down really low in the real situations. So it doesn't look right. It doesn't look right, starting from the straight forward and straight up. So let's change that as well. In that case, it might be better if I use the remap right here. Remap the 0, 1 value from, like, let's say 45 degrees to 120 degrees. See what happens. So starting from 45 degrees. Then slowly end it up to 120 degrees. Okay, now these part will be, I think you could parameterize it so that you can control it or randomize it based on based on like conditions, or if you have multiple number of plants. So let's have these as for parameters for now, so that you can control them. Let's call this S body angle, E body angle. I don't know, maybe 60 to 150 might be good. Right. Okay. And well, it might also make sense to just change the first angle for the S body angle. I mean, maybe you can just start off by initial angle, because it's always starting from the straight up. But maybe I just want the initial angle to be 60 or 45. So let's, in that case, I need another conditions for the rotation here. If the point is at the tip, it's at the starting point of every geometry, which I think is when the point number is equal to 0. So that's simple conditions. If PT num is equal to 0, I could say I want to rotate using this S body angle. There you go. And in that case, I can make this a bit smaller, like if you say you want to start by 45 degrees, and maybe I should be using different value for this one, I guess. Yeah, I think so. So this part and this, I should change the different name for this one. Let's say instead of using S, how do I say, W as a whole body angle. Okay, or maybe initial as I. Okay, let's set some ranges for these parameters. So now I can set up an initial angle for the body, I mean the whole plant. Then I can also set the range for the deformations, for the bending. Okay, sounds good. Okay. Yep. Now, let's go to the next one. I'm going to try to change the head part. Control the head part. In this case, first thing I need to define is the bending, the initial bending angle, which happens right here. So let's have that as a parameter as well. CH, should make it CHF. And how do I call this? Connection, connection angle. And I'm gonna call this 150 for now. Okay, now another one. We're going to have a body angle, which I want to replace with these ones. Okay. So let's do that. Now, one thing I forgot to do is to think about the number of points, which I forgot to do, I think, because right now if I change the number of points, I think the angle also changes, because I haven't set any, but it doesn't changing. It's not changing. Maybe I did correctly. Oh yeah, actually I do have these divisions with the point number, so that's fine. Okay, so what I need to change is this part, the angle body. I need to create a angle for the head. So let's do that. Hello everybody. Thank you for coming. So same as these, just going to copy all these, and I'm doing pretty much the same thing as what I did for the body, so I'm gonna copy these and just change it to head. Head. I guess there are some procedural like relation between the head angles and the body angles, but for now I'm going to control it separately because it's easy to see the result at this point. Maybe later I can think about the relation, like some mathematical equations, how these are connected based on the time frame parameters and the scales and so on. But for now, let's just control it separately. So have several values based on the head. Okay. Yep, and let's change those values here. Let's make the maximum 200, like everything 200. Okay, now let's also change this value to angle head. Okay, for now, doesn't change anything. So I need to, first of all, I need to think about the initial value. First thing is this value here, which could be really lying onto the initial geometry like that, right? And I could think from the start frame, which is 1. Let's say it also bend with the same frame as the body for now. Maybe I want to increase it later, but it'll be easy to see the result. And now I want to change the angle. Initial value, maybe I want to make it to 10. And in the end, in the 60 frames. Okay, now actually what I want to do is to rotate in the other direction, not clockwise, but to the counterclockwise, meaning going negative like that. And I actually don't want to rotate bend like this, but I want to keep the bend geometry something like that, or a little bit bend it like this. But what I would need is to change this connection angle to be procedurally rotated based on time. So to do that, I think I need to remap the frame with use the frame value for this connection angle as well. Right. So let's do that. So currently this is the starting connection angle. So I'm gonna rename this to S connection angle. Move it to, or let's copy this part, the whole part for the connection. So let's call this fcon, and for the angle S head, E head, call this scon, econ. Actually, for these frame-based value, maybe I can rely on these one. Maybe I can just use the same value as the head rotation values. So maybe I'm gonna delete it, and then this is fine. Just gonna rename this to fcon. For this one, I'm gonna call this angle con. I'm gonna remap the fcon with this S connection angle. I don't need radians here. S connection angle to an E connection angle. Alright, and just to make it easier to think, I'm not going to use negative right here, but instead I'm going to use negative right here. Okay, so meaning I have to have these values as negative values. Okay, so let's do that. And I need to make this as angle con. Now I don't really need to divide it by PT length because it's just 1 point right here. It's just a rotation on one point, single point, so I don't really need to divide it by a multiple number of points. Okay, so let's set some parameters. In this case, these value will be better in negative, I think. So the minimum will be negative and maximum positive. Let's also do that for everything, just in case. For all the angle, I'm going to make the minimum to 180 negative and positive 180 for the maximum. Okay. Alright, so if I change this, I can now set an initial angle for the head, and then in the end I would like to have, okay, this is not working. Okay, econ angle. Okay, it's not working. Let's see why. That is because so I have this angle con right here, which is used it right here. At least this value is being used. This value seems not, for some reasons. Okay, and it's supposed to change from one single frame to 60 frames. Now let's change the head angle to 0 and 0 so that I can see the result better. Okay, so obviously the angle is not really changing. It's not transforming, so maybe I did something wrong here. What's that? What will be, okay, this one. Actually, I have to change this one right here with fcon. Forgot to do that. Okay. Alright, so it's changing. It's too much. First thing first, I will make this angle and also the head angle, the initial head angle, to be a little bit rotated, and in the end it's a bit negative. Okay, then on the 60 frames it's rotating too much, maybe somewhere around here. So now I have kind of a whole setup for the body, just for the bending at this point. Yeah, so the body rotates from 45 degrees to some 60s, and the head part is rotating more drastically, folding up from here to here. And I can also change the timing when the head rotates. Maybe it could start from like frame 30 to 120. Now initially the head doesn't move, and from 30 we'll start to rotate like that. Okay, so that's what you could control. And maybe based on maybe you could also add something like ramp parameters to control the smoothness of bending. Maybe starts slowly, bends slowly, and finishes really quickly, or like a sine wave. If you want to do that, you could apply a ramp parameter in between the angle body and F body. Same for the head and the connection. Initially that's just the linear value, but by changing its curve you could also change how it's being animated. Control the speed of the bending based on the time, which is probably necessary to make it realistic. Okay, and here. So you have 3 ramp parameters as well, which is a bit too much as a parameters, but at least it's better to have something you can control. Okay, so let's change this to something like sigmoid function. I'm gonna make this B-spline. So start slowly, quickly go quickly, and end slowly again, which is used in a lot of animations, I think. Which is called as a sigmoid curve, I think. Okay, let's see what happens. Alright, so that's how you bend it. Now, in the next step, I would like to scale this based on the time frame. Okay, which I could probably do this inside the wrangle, or maybe I can separately do this. Let's see if I can do this in the wrangle, see if it's better to do it right here or not. Probably I can do functions something like scale to the local transform to scale the whole thing. Local transform. Let's see what happens. So just gonna create some pseudo value based on the frame. Fit frame from 1 to 100, 0.1 to 1. See what happens. I forgot if the scale works like this way. Let's see. So initially it's pretty small and scales up really fast here. I guess that's because this is a local transform. You start from really low value and then scale up really fast, which doesn't really apply to the real growth or linear growth. So maybe using the local transform might be hard to control it. Might be hard to control the total like scaling speed. I think it's better to control the speed based on its length, probably. And how would I do that? So I have from one frame, the first frame to the 100 frames, and when it cuts to when you can see that the scale value from 99 to 100 is pretty big compared to 3 to 4. Yeah. Okay. It's pretty hard. Let's not try to use scales right here, but well, when it comes to the animation export, maybe I might be better doing the animation value setup inside the rigging attribute. Yeah. So let's think how I could come up with that. Come up with a better result, better scaling value here. Just need to give a right value for each frame for this scale. Okay, so 1 will be the final result. Okay, and let's get the final length value for the total curve, which is which I can get it by primitive length. I have these parameter value here, one for the body and one for the head. Okay, now so probably I need to do something related to these based on the number of points and so on. Okay, now let's get the parameter, which is inside a primitive, and the primitive number is prim. Okay. Okay, and let's create a pseudo scaling value, which I made it previously based on the frame. Let's say from 1 to 100, I want to use from 0.1 to 1.0. Now actual length of this parameter per primitive or the curve will be the final parameter multiplied by SC. Okay. Okay. So probably I could use this value here. Which is where is it? Right here. Changing from 0.1 to like that. Okay, now let's see how I can use this. Well, in the end, this will be the same value as the parameter, right? But in the end, I want to make the value as 1, right? I think it's just better to draw it. So curve, let's make it straight, and want to start from here to here. Okay, if the whole size something like this, and if it, let's say this is 0.2, this 1, then each scale right here is also 0.2. Right. Which means maybe I can just scale the initial point with the scale value and just keep 1 for the rest of the points. Maybe that's how it works. Let's try that. So in that case, I can make this coming to the starting point right here, and then use this scale value to here. See what happens. Okay. And now, yeah, that I think that seems to work. So I just needed to change the first points scale, and everything just follows that. Okay, that was easy. All right. I was thinking too hard. Okay, so now I have scales and bending. I think it's time I control the scaling steps. The frame and the scaling ratio through the time. Okay, let's give that number. F scale. Just gonna copy all these again. Well, just copy from here. Is it here? Gonna call this FSFSC and starting scale. SSC, ESC, SC, SC, FSC, and yeah, I think it's better to have the ramp parameter as well for this one. And angle, not the angle, but actually I want to have the scale value, which is from how do I call this? I think I should call this frame. Alright. Really bad at the name conventions, as you can see. And replace this with an SC. Alright, that should do it. In the end, I want to make it as 1, starting with, I don't know, maybe 0.2. You could also make it as a sigmoid curve, maybe. I'm not sure, but can try. And for the frame, let's say I want to start scaling from the first frame to maybe 100 frame. Okay, let's also set some ranges. So these are the scaling, the ramp, and the frame. For the frame, say maximum is 200. Okay. Alright, but that looks Okay. It's just a bone right now, so it's not really interesting yet. But I think I have the base now for the transformations. So I think it's time I can use this with actual geometry for the plant. Okay, so let's do that. So it's time to model some plant bodies and heads, which is a fun part, but also I'm not really good at those modeling part. Let's do that. And actually I don't really need these parameters anymore. Let's just delete it. Okay, so how would I do that? Go back to the rig doctor, and I think there are many ways to do this. I mean, you don't really need to rely on the initial curves or points, but in the end I need to move the plant geometry, the body geometry line to this line, align to this line, and align to this head curve. So what I'm gonna do, I'm going to create the geometry out of these curves for each body and the head. Okay. Alright, so let's do that. Now, maybe I can make the geometry separately. So split the part. So I have the body on the left output, and I have the head on the right output. Starting from the body, okay, which I might also want to introduce some foldings on horizontal direction. It might be better using KineFX for this one as well. So let's see how I could do that. First thing first, let's go back to look at the plant shape. So it looks like a heart shape. Initially, it's been folded like this. Interesting. So started folded like that, and then opens up like a shape of a heart. So I want to create something like these. Yeah. So let's think. And when you look at this, you also have some bend ridge right here on the middle. So I think it's better I just make some left side or right side first, and then mirror it to the other side, considering these ridges and the heart shape. Okay, so what's the best way to create a heart shape from here? Let's see. And in the end, I also want to bend this, right? Maybe using KineFX or maybe using other ways. But if to animate in other DCC tools, maybe it's better using KineFX for all the animations, maybe. So let's think about how I could do this in KineFX, right? So to use KineFX, which the shape is something like this, and fold it like that. To fold it like this, I think it's better if I have a cross curve, something like these. Something like a bone, the body bone structures, which transforms straight to rotated, rotated to straight, straight to rotated. And then connect those curves together to make a plane, make a surface. Right? So let's do that. And also needs to be a shape like these. Okay. Alright. So I think I'm going to first create this profile first, the shape, the goal shape first. Then from there, I'm going to try to create the bone structures like these from that profile shape. So to create a heart shape, heart-like shape, I think I'm going to first create just a wave-like shape, the mountain-like shape that like this, and then transform the upper part of the mountain to go upward to create more like a heart on the top. So two steps modification, two-step transformations that I'm thinking of right now. Let's do that in Wrangle, see if I can do that. This is the first step, mountain. And for the mountain, simple mountain, I can just use sine wave, I think. So I can get the point number and divide it by the total point number to get where you are right now with the normalized value. PT num divided by float and points -1 will give you a value in between 0 to 1 based on its positions, I think. And then I can convert this t, which is in between 0 to 1, to the angle value so that I can use it with the sine function. Then use it with the height, use it for the height to move the point on which direction, X or Z. Let's see, well, either way is fine. Let's just move it in X direction. Okay, now that's too much. So let's control the height parametrically. Okay, now that's the initial mountain. Next, I would like to move the upper part maybe, or the whole part gradually to like left top corner, left top direction. And maybe the amount of strengths, amount of transformations being affected by from top to bottom, maybe. So let's try to do that in the same Wrangle. So I already have this t value here, and what I would want to try to do is to use this t to create additional value. Okay, I also have an angle right here, so let's see. I'm gonna create v in this case using the same angle with the sine functions, and let's see what happens if I add this v to the y direction with some v value. Okay, now not that bad, but not that good. at the same time. So what I could do here is to create, multiply some t-based value here to the v and see what happens. So I'm gonna multiply the t, see what happens, and becomes a bit better. This means is that if it's close to the starting point, you have less strength for this vertical translations. And if the t is at the top, you have more strength, you have more weight. Now you could also apply some power functions to this. See what happens if I use 2. Now it becomes more gradual. 4, nah, 2, 1.5. And combine with these v, maybe those are enough parameters to control the heart-like shape for us. Okay, so you have v power. The range is in between 0 to 4. Okay, I think it's good enough. Alright, so I think I have the base cross shape right here. And if I use it with a mirror function, it does look like a heart shape, which is pretty close to this shape, I think. So I'll say it's good. I mean, if you need more control, then you can introduce several more, like something like ramp parameters to control more of these curves. But for now, just gonna go like this because it's easy to control here. Okay. So now that I have this, it's time I want to control the bending of this shape using KineFX. Go back to the half-sized profile. Let's try to create this with a KineFX. Alright, let's see how I can do that. Well, first thing first, I'm going to create this as a surface first, the flat surface first. So I need to close this curve from start point to the end point. So I'm going to use a primitive properties to convert this into closed surface. Okay. Then what I can do is to just create a contour on this surface and use that contour as a KineFX like curve. Now in that case, I might not want to have these points, like single points on the end, but I might want to have some gaps so that I have at least some thickness in the end. Okay, so let's have that. Let's create that. To do that, maybe I can just let's see, I can maybe transform this to the x directions a little bit, just a little bit. Alright. Now it didn't really work because it's not relying to the original positions. Okay, so I think I need to do it right here. So the x is controlled it right here, so maybe I can introduce some offset value. Okay, and also want to have a little bit of gap here. Maybe not here, just on the starting point. So the offset should be added just on the starting point. Or I can just multiply this by 1 minus t. Oh, offset. Oh. There you go. So I have some offset right here, no offset on the end. Okay, now I think I also need to add points right here so that you have some thickness here. So in what timing should I do that? I mean, this is at the origin, so I can just add a single points on the center, on the origins, and just merge it with these, or maybe not. I can just say, since I'm in the point wrangle, I might need to do this in a different wrangle to add the single point. So I'm gonna create the primitive wrangle. Just like, doesn't really look elegant at all, but it's fine. Create original point, or point at the origin, then add it to the vertex, add it to the primitive. Okay, now should work. Alright, now you can create the contour for this shape. Okay, to create a contour, maybe the easiest way is to use divide node. And instead of using convex polygons, I can use this bricker polygons. And for the size X and Z, I can make it really big, so it's not gonna be affected. But instead, I'm going to change these values, Y values, which will define the steps of the contour. Okay, now probably I want to know the whole size so that I can also have some curves on the end, on the top side. So based on those bounding box size, I can maybe define these steps. Okay, should I do that here? Yeah, maybe. So I can use bbox. What I need is the dy size of this geometry. So let's do that. Getting the self node and dy size. So that's the whole size, and maybe I need to offset a little bit, just a little bit, so that I can get the top part, and divide it by a number of contours you want to have, number of KineFX lines you want to have. So let's say like, I don't know, 20. Okay, and let's check if I have a curve on the top. Yeah, there you go. Okay, now next thing I want to do is to just retrieve those curves, the horizontal curves, and just delete everything else. So convert it to line and just get those curves which is horizontal. Anything else, delete it. And not sure if you can determine the angle, but I'll just do the wrangle way. Get horizontal. In this case, you just need to get the first point and second point and check the directions and calculate with the dot product if it's horizontal. If it's on x directions, the value will be either the value of the dot product between the direction and the x axis is either 1 or -1, so it's easy to determine. First thing first, get all the points related to these primitive. Get the first point. Get the second point. Get the actual position. Get the end position. Get the direction. Now calculate the dot product between direction and x. And maybe I can make it as an absolute value so that if it's aligned to the x direction, it always become 1. So if the d is less than 1 or less than 0.99999, then delete it. And should be able to just get the horizontal curves. Okay, and I want to make sure this is from the number, the order of the primitives from the bottom to the top. So sort it out. The primitive using by y. Now if I use polyloft, should be able to connect all these to make a surface. Now this part is not really making the curve, so I might need more divisions for this, maybe later, like 50 or 40. Yeah, if using these ways. That's a lot of, maybe I want to it might be okay for the resolutions on the top part, but maybe that's too much on the middle, so maybe I want to reduce the number on the bottom part. But the divide node cannot control how much, like the you cannot create a gradational steps, so I might need to do it in different ways in order to have those gradual steps, gradual like contour steps. Yeah, well, what's the best way? What will be the best way to do that? Let's see. Let me think. I think there are some ways. After having these, maybe I can just move them. Gradually move. No, but it has to be before. Yeah, so maybe instead of using divide node, I should use something else, like trim it with a boolean. Okay, Let me think how I'll do that. Well, maybe I'll just come back to that later. For now, I'm gonna go set up the KineFX first. So let's make this 40 or 30 for now, which is a bit jaggy right now, but it's fine for now. Okay, so I have these curves. It's time I'm going to convert it into a KineFX bones and try to like modify the shape, change the shape. You could make a line going up, then for each point get the curve positions in X and make a line curve to the curve. You make a line on going up for the I see. There were resolutions of yeah, that's true. Yeah, I'll do that. I'll do that. Thank you. Thank you, Ellen. I'll do that step. Okay, maybe I should just do that right now. Shouldn't I? Let me see what else would I need to do. Actually, for the KineFX of this shape, I just need a single curve, now that I realized. If it's just a single axis rotation, just like you see here, you see that it's not really a complex bendings, but it's just a one axis rotations. In those cases, maybe I can just have a single curve, maybe on the middle, and just use it as a base bending curve. Maybe I'll do that. In that case, maybe I can just, I can just use the base shape as it is to deform. Alright, maybe that's better. Okay, so those cases, I'm gonna create another line. And in this case, I'm going to make the direction to x 0, 0. And move this to match with the this shape. Now in that case, I didn't really need to have these bottom shape, but I guess that's fine. Okay, and let's also change the scale. Okay, so forget about the uniform scale. Now that sorry, now that it's now aligning. Think I need a water. let me get some water. Alright, alright. So I have this center point, center lines, which I want to use it as a KineFX curve. Now let's resample this so that I have enough points for the bending. For the bending. Okay. I probably could the same aspect ratio, I mean the body bone resolutions that I have for the initial, the body part and the head part KineFX here. Okay. All right. Now that I have the base curve, I think I can use the same rig attribute. But first thing first, I'm going to convert this into a KineFX curve using rig doctor. And done. Use initialize transform. Yep. Okay. Then try to create some bending functions for this curve. Okay, so in this case, just a single curve. Wait a minute. Yeah, it's just a single curve which I want to rotate, bend like that, bend like this, like this. Okay, so this is the starting point, and I want to bend like this. Think. So let's see how we can do that. So we have two directional bending, one for here and one for vertical, which I already have. So having these two bendings, I think you should be able to have some rich results as a final geometry. Okay, so what should I write? Forget about the time frame for now. Let's try to rotate the local transform. In this case, the axis is y. So and the angle, not sure what's the right angle yet, so let's say 90 degrees. And for this one as well, you want to divide by the number of points. So get the point number. And this is a little bit easier than before because you don't have multiple number of parts, you just have one single directional curve. So divided by non-PT. And with the axis, okay, so that's 90 degrees. Maybe you want to have more points. Okay. And let's try to increase the angle, see what happens. 150. Okay. Now actually, I probably want to fix the initial angle, maybe something like 0 or a bit negative, so that you have some ridge curve, a ridge angle. So make the conditions whether the point number is 0 or not. So if point number is equal to 0, use something else, use the angle that I have right now. Okay, so if it's 0, maybe I want to make it as negative value. Yeah, maybe. Okay. Now, might want to also control the angle ratio based on the position of the points. If it's at the end, maybe I want to have more curling. And if it's close to the first point, maybe you want to have less curves. If I look at these, I can see that there are more bendings on the tip, on the end of the curve, on the edge of the plant, and not much on the center, probably like that. So let's have that kind of information. How do I get that? Well, one thing I might want to have is the same thing that I did here, the length value, which I haven't used on the first examples, but maybe I can use in the second example. So let's bring this up somewhere around here, and this one is using x directions for the length. Okay, and also let's also measure the whole length for the parameter, for the primitive, and try to use that information together with the angle. Okay, so for this angle, I think I want to increase the value more and more based on the position of the point. Okay, so to do that, I could say, well, let's see how I can do that. First of all, I need to have some informations, which ones at the starting point and which ones at the end point. So let's start by calculating the basic informations, dividing the point number by the number of point. Minus 1 will give you a value in between 0 to 1. Right, and then use this t value to this angle. See what happens. Okay, and to make it simple to see, let's set the first angle to be 0. Okay, so now having these t value, you'll be able to have more effect on the endpoint, less effect on the starting point. But now it's a bit hard to control the overall angle with these numbers. It's not really transparent anymore, and I think you are going to have some problem if you change the number of points. Well, not much. Just a little. Maybe that's fine, but it's a bit hard to assume what's the final angle here. Okay, that is because you kind of need to know the ratio for each points. I mean, each points will be calculated by some t value, okay, which could be something like 0, 0.1, 0.2, 0.3, and in the end you need to have you need to divide all these values just like you did with the point numbers right here to normalize it if you want to use it as a weight. So instead of using number of points, I think you need to divide it by the mass addition of the t from point 0 to the end of the points. Okay, so which I cannot really do that here because I don't have the t number for the other points right here. So I think I need to do it beforehand, calculate the t and add all those values together. So try to calculate the t value, which I might want to also use like something like ramp parameters later. num m points. Okay, and I'm going to use the attribute promote to get the addition or sum of all the values, t values. Which as a result you get is 8.5 as a result, which is by adding all these t value calculated with these. And that's what you want to use with these divisions instead of the number of points here. So float t is just the attribute t, and you also want to have a t sum, which is on the detail, and use it right here. By using it, I think you should be able to use this angle more properly. So if you set 90 degrees, the total result will be 90 degrees, even if you use like weighted t. And even if you change this t value based on some ramp parameters, you should still be able to control the whole angle, I think. Even if you use sigmoid curve, still is 90 degrees, right? So I think it's more better this way. I don't know if I need any ramp parameters for this, but so if I set it in 180, okay, you have something like these. 240. Okay, and maybe if I have a ramp parameter, you could control more in detail. Yeah, it's better. Now I can go back to introduce a negative value for this one, something like -10, so that I have some rich angle right here. Okay, so let's give some parameters for all these. I already have these. So this one is the ramp parameter is the parameter. How do I call this? Bend weight. And this one is the plant bend. I'm not sure. The body bend, body horizontal bend. Okay, and I can make this as a parameter. Initial angle. This one is the total angle, I guess. Okay, so the range is in between minus, I don't know, 300 to 300. Okay, set the initial to -10 and set the target to something like 260 or something. Okay, not bad. Now that I have these bending value, let's also introduce the frame based value so that I can control the bending from first frame to the end frame. So let's give a frame and how do I call this? If bent fit the frame using the start frame, to the end frame and make it normalized. And you might also want to control the starting angle and the end angle for this one and this one. Maybe I can fix the initial angle, maybe not, I'm not sure. But at least for this one, I wanna control the angle, maybe from 0 to something. So final angle will be fit 0, 1 if bend to ST-ang to ET-ang and use that. Okay, now I can delete this one. Instead, I have 2 angle value, which the frame wise I can say from first frame to, I don't know, like 60 frames. Then for the angle, maybe from 0 to 360. See what happens. Okay, so something like that. Okay, I think it's good to have it as an initial setup. Now I can try to actually morph the geometry using those 2 bending informations. Alright, finally. Now, first thing first, I am going to bend this geometry using this horizontal body bendings. Well, actually I haven't made the head one yet, but let's just morph the body one first. See the result. Okay, so what I should do next is to so since I'm going to morph this or transform this, deform this, I need to have a bunch of points to be able to bend it. So let's remesh it, I guess. And I think I don't need that much points on the curve, on the edge, I believe. So maybe I can, and actually I don't really need the first point. I'll just leave it as it is. Okay, so maybe I can go back here and resample this curve itself. Reduce the number of points. Yeah, something like that. Then using the same primitive here, and maybe I can replace with these one. Doesn't make much changes. Then do the remesh for this. I'm just gonna make it something like these, but probably better to re-parameterize these values as well later. But for now, having this much number of points might be okay. A little bit more, maybe. Okay. Now to bend the geometry with a the rigged bones or rigged skeletons, I can use a joint capture by joint capture proximity. Okay, now the first input will be the KineFX curve, is it? No, that's geometry that I want to control. So this one. Okay, and the second input is the original KineFX geometry, which hasn't moved yet. So which is this one, I think. Maybe I should do the weight calculations beforehand. Yep. And the third one, the third input will be, no, actually this is just the capturing, so that's fine. This is just fine. Now the problem here, it's not covering everything, so I need to increase the drop off more. So that covers the whole step, the cover whole everything. Okay. Well, the color doesn't really look gradual, so it might not work properly. But let's see. Only if I can control it here, maybe not. Well, let's see what happens. And to actually deform the geometry, I can use bone deform. Connect this to here, and for the second input, I can connect the original rig. And for the third one, I can connect the actual moving deformed rigged. And not bad. Yeah, not bad. Pretty much looks like what I expected. Okay, it's fine. I mean, there's a kind of a steep bend here, but you could just solve it using, I don't know, normals with low cusp angles, high cusp angles. Yeah, that will just solve it. Okay, that's good. Now, let's also use the second rig together with this one. Now I don't really have a head yet, but let's just try just with the body. So okay. So the initial curve is like that. Okay. So just need to do similar things. First, capture it. Capture the geometry. Capture the geometry. And which in this case, I think I need to choose the one that's not moving. I don't think I can use the deformed geometry for the capturing, I think. Well, let's see if I can do that. I mean, first I'm going to just use the same thing, just like that. And then connect this rig doctor to the second input. Okay, and that will create a bunch of color map here. Okay, now let's bring this up and use the bone deform. This comes first. The second input is the original rig, and the third one is this one. Okay, and see what happens. Yeah, and this also seems to work. Now, in order to combine this, actually I haven't tried it, so not sure if it's gonna work. I was hoping if I could just connect this one here, but I don't think it's gonna. But it is actually working. Is it? Somehow it's working. Is it? That's because it's not bending. I mean, in x direction, so it can still capture with the proximity node. So okay, that's fine. That's good. So this works. So it's having two steps, deformations here. One for the horizontal bending, one for the leaf bending. Okay. And actually, I should make this mirrored. For the actual leaf. Deformations. Now something went wrong. Okay. I think I need to mirror this one instead. Yeah. Mirror after the normal. Okay. Looks better. Now initially I have some weird bending. That's for the head, so I'm missing the head right now. So next step is to create a head, but also I need to also control the bending result, which is a bit weird right now. I mean, it started off with the curled leaf but ends up flat, but it's the other way around right now, so need to flip the angle. The end will be 0. The starting will be 260, and there you go. 0 might not be good. 10, 20, yeah, something like that. Okay. Good. Let's go to the head. So getting messier a little bit. It's getting close to the result, the final. You still need to lay out these plants in the final, in the end. Okay, let's organize this a little bit. So this is for the body. This is for the head. And this is for the hole. So what I would like to do is next. What I would like to do next is the head part. Let's do that. And what is these? Okay, so I don't really need these anymore. I'll just delete it. So the head. The head. Let's skip the bug part. So the head looks like these. The head looks like these shapes. Interesting, really, really interesting. So the shape, if I look from here, it looks like you have some curved shape. And you have, how do I saw? Like a shell-like shape. So it's not really the full arc, but more like a shell. There's any more information, if there's many more, and inside looks like these. Look more like a mouth of a duck. This one looks good. Okay, so the profile looks like, okay, consider it something like a shell-like shape. You have some arc right here. Okay, for the arc part, we can control that using the bending, which I already have. So I should just create these shell-like shape as a profile. So let's create the left-hand side like I did for the body and mirror it later. So how do I do that? Okay, so same as I did for the body, maybe I can first create a arc, then transform that arc, translate that arc to X directions and create some shell-like shape. Maybe that's the step I could do. So I'm gonna copy the one that I have here, which I can reuse some of the part, I think. So these part I should skip. I should also skip using offset. Okay, now maybe I have some small amount of mountains, and what I want to do next is to offset these to a perpendicular directions, perpendicular to this curve, I guess. And then move it to that directions. But since I'm using a sine wave, I don't really have the perpendicular directional informations at this moment. Right. Well, I could assume what that value is by checking the next point value, which is to say, since I'm using t right here, I can say t2 is pt num plus 1 float n points 0 minus 1. Now, one thing that in one situations this doesn't work is that if we are looking at the endpoints, maybe right here, because that doesn't have a next point to calculate the gradient. So maybe I need to make a specific point number which is clamped using these functions. So the minimum of the PT_num will be -2 of the total number of points, so that you always have the next point as a result. So let's replace this with PTN, and then now in that case you are going to miss the angle, I mean the height, so you probably need additional t value here using the original point number. Okay, now for the T1 and T2, you could calculate an additional angle. You could create additional height value. And then create a gradient between those two informations. Now, to do that, you need those point informations as well. So okay, now the gradient is set position.1 x, position y, z minus set position.2.x, position2.y, position2.z, and you can now add h1 to the first point and h to the second point. And normalize it. Okay, so this will be the gradient between 2 points, I mean the direction between 2 points. You can now then rotate it to get the perpendicular directions using x-axis, I mean z-axis, and rotate the gradient. Now finally I could try moving this point using this gradient with some point, and it should give you some offset value, but I should do it beforehand. That's it's not what I expected. Okay. Okay, first of all I needed to normalize it, but let's see, what does this gradient look like? If it's really perpendicular to this curve. Probably not. Okay, it's not really perpendicular. So let's try not to rotate it and see what's happening. Okay, that's not correct at all. It's supposed to be aligned to this curve. So this part is wrong. And that is because I didn't multiply this one, I guess. The scaling part. Okay. Now it looks correct. And if I divide it, okay, now it's perpendicular. Now I think, well, let's also normalize this. Now I can move this point toward this gradient with some distance. Okay, now it's gonna offset, and now I have the original curve and the offsetted curve. I can then merge these two to create a something like lofted geometry using something like skin, which looks like what we have here. Yeah, close to what we have here. We don't have to care about these curve because that's gonna be controlled with the bend on the rigging part. So pretty much this is what we should be having, I think. So you can control this one and how much you offset. Let's just use V for this one. Okay, and I guess that's pretty much it. Okay, now the bending part, I guess, or the needle. I don't have the needle for this one yet. Yeah, just some simple pointy needles on the edge, which I can make it separately or using these geometry. One of the easiest way is to create additional like geometries per edges or per maybe per edge, yeah, to have some pointy edges. So probably I can do that here. If I want to create a needles per edges, I think I need to convert this into line first and move these curves, move each lines to again perpendicular directions and make it pointy. That's it. Now to get the perpendicular directions for each lines, I don't have that information at this point, so let's see. I'm thinking if there's any way without using wrangles, but I don't think I have any ideas. So again, I'll just use primitive wrangle. needle. Okay, so since we are dealing with the line, you have 2 points for each primitive. One for the first point, one for the second point. And copy this one. Get the second point. Okay. Get the tangent vector value. Let's get the perpendicular value, which I already have the method to get that. These rotations. I'm gonna create a rotational matrix to rotate these directions. Okay, now I can use this perpendicular directions to create a single point somewhere around here to connect these lines with those points to create a primitive. So, new position is equal to the middle position of this line plus perpendicular directions multiplied by some distance, create new point to that position, then add it to the primitive. Add vertex. Alright. And increase the distance, not that way. Not that way. To the negative direction. Okay. Now I can use primitive properties to close the shape to make it like a needle, and then merge it with the shape, the flat shape. Well, it's just a pretty simple like look, which doesn't really look like the current needle shape like these, but I think it's a good starting point. Might want to make it more pointy for each needles, which in this case, what should I do? Well, first thing first, I want to make the distance, the lengths of each lines to be the same as much as possible, which is not at the moment. So I can reuse the resample node. And set the maximum number, like 20. Okay, make it even. Now, maybe I shouldn't use skin anymore, but instead polywire. That's because we're not not the polywire, but polyloft. So that the two curves shares different number of points. What's up with these edges? this is a new curve. Why am I getting... Where am I getting these offsets here? This one. This one's giving an error. Maybe I should have a same number of points for the end points and the... Oh, wait a minute. I think I just need to connect it right here. Okay, that was it. In that case, maybe I can just use skin as well. Yeah, okay, I guess. And what if I change the number 10? Yeah, still, I can still use it. Okay, then I'll use skin instead. Okay. Well, as a test profile, I think that's fine. You could control the number of points. I mean, if you want to have more details on those needles, maybe you should have additional process right here. But for now, I'm gonna go with these. Okay, so let's create a rig for those curve. I mean, for those a head part of the plant. Okay, so pretty much I am going to do the similar things that I did here. So I have the line. So I'm gonna copy several stuffs that I have here. Actually, I really didn't use the lengths here as well, so forgot why I need it. Anyway, I'm gonna copy everything that I have here until the rig attribute wrangle to here. Okay, and for the base to match with these lines, I am going to use this one, I guess. Yeah. Or should I cover the needle part as well? Maybe. But it's fine. I'll go with these. Okay, and resampled, calculating the lengths, which is not necessary, and bend weight, which is good to have, I think. Let's keep it. Break doctor, and let's rename this to head. Go. So this is where I should really change. So let's check how it should rotate. So starting with a really closed surface, I mean closed folded shape, completely folded, then open up like mouth of a duck. Okay, and it's not going to fully open. It's like it's opening like 45 degrees in some part. still closed. So 45 to 60 degrees opened. And it's pretty simple bending. Maybe just bend at the starting point might be enough. Yeah, so let's do this. Okay, so I could use the same setup that I have for the body, I guess. Let's see, the L angle, the I angle. This is the initial angle. So initial angle, I want to make it really closed up, close to 90 degrees, maybe 80 degrees. And checking it. So in terms of the frame, maybe it should start opening after the body has been opened up. So maybe from 60 frames to 120 frames. And the angle for the start and end. Maybe I could start with the really low angle, like 5 or 10, 20, 15. Then check the 120 frames. Now this part, I didn't have it for the body, but I want to control the initial angle value with the frame, which is this one, which I want to control with the frames. So let's have that value. Okay, I'm gonna copy value right here. I have a comment. The needles can be made with the poly extrude, but it's a bit convoluted, pre-computed, bit directions in N. Ah, I see. Okay, yeah. You're right. Poly extrude divide into the individual components, extrusion model, point normal, existing level transformers. I see. How have you been learning? I see. Thank you, Alan. I think your method is much better. I think I'll try that later. Hello, Kalev. How long have you been learning Houdini? Probably 7 to 8 years now. Yeah. Still have tons of things to learn. There's so many things you can do in this software. Pretty awesome. What was it? Frame for the initial bending. Fi bend. Now the name convention starts to mess up, as always. Anyway, the angle, F IT angle, I bend. Maybe I should just make those names more longer so that you can easy to read. And the angle that I want to use is FIT angle. Okay. Right. Okay, and these are the frames, which probably I can share the one that I have right here, so maybe I'll just copy and paste those value here. And for the starting angle, which was what? The angle for the starting frame, which I want to make it 90 degrees for 80 degrees. And now I don't need to have this parameter anymore, just delete it. Let's set the range from minus 300 to 300. Okay. And on 120 frames, I want to open it somewhere around here, I guess 45 degrees. And do I need to change these values? Maybe not, just a little. I could have a whole geometry a little bit bended, I guess. So to do that, I could make it to something like 30 degrees for each, and go back to the position where I'm calculating the weight, which in this case it's from 0 to 1, but I think I can make it everything to 1, which gonna make the whole the steps of the angle bend in the same manner. Okay, I think it's better for the head. So starting with 15, and in the end, yeah, just keep it as 15 or something. It's better, or 20. Not much changes. Yeah, make it a little bit opened up. 30 degrees. Okay, with a little bit of curve. How's that? Okay, so let's go. Let's try with these. So now I have a bending movement for the head. Let's try to deform this geometry that I have here. Okay, so have you worked with the HDK to make compiled nodes in C++? If no, do you wish to learn it for some things that will be hard to make? Yeah, I would love to. Yeah, there are things which should be better written in C++, like some of the solvers, some of the complex matrix related calculations. And for those stuff, yeah, it will be, I think, I do feel it's much better to do something like in OpenCL or C++, but I don't know how to do that. I haven't tried myself making as a plugin or something, which I would love to do at some point, which I don't know how yet. Need to start learning it at some point. Yeah. Well. Anyway, let's see. So I think I'm gonna come back to how I make a needle later, but now let me try to create if I be able to bend this geometry using the stuff I have here. Let's first fuse it, and then remesh it. Okay. Then same things that I did here. So I have a joint, capture proximity. The first input is the geometry that I want to bend. Second input is the original rig. And the third input, no third input. But now I need to use the bend deform. which this geometry comes to the first. The deform comes for third, the original comes to the second. Okay. Now let's also recalculate the normals and mirror it. See what happens. Now using mirror might not be a good idea because actually the needle is more like a handshake cross. It's crossing like a handshake if you look it closely. Maybe it's better to see in the image like that. The needle is crossing to each other, so maybe using mirror is not a good idea in this case. Well, I'll come back later for that. Let's just see if the deformation is working. Okay, so it's okay for this part. Now let's combine with these leaf shape and see if it can be used with the final joint, final deformations. See what happens. Okay, something weird. Okay, so yeah, something's not right. Yeah. Probably it's due to how it's capturing the geometry. And I guess this is where it's giving you the errors. Some part is having crosses between up and down. And for the body part you have you are having some part is going till bottom, some part is going till the top. I mean, this is the connection point, and for the head part, these part is going to be affected by this body bending. The body bend part of this bend animations, and the bottom part, the body part, is also affected by the top part of the body is also affected by the bend of these head bend, which is applied here. I mean, explain it here. So I think it needs to transform based on some group, target group, which in this case I'm capturing everything right here, so it's a bit hard. It's a bit hard to do. Maybe I should just deform it separately so that it'll be easier. In this case, maybe I should separate the one for the head and one for the body and do the deformation separately. Might be easier. Let's see if I can do that. just get the part. Oops, maybe it's so. First of all, for the body, and let's see if this works. Now some part is messed up. That's where you couldn't catch with these body capture proximity, which is somewhere around here, I think. Now, how do I show the colors that used to show up? I don't know how to show the color anymore. Join capture proximity. So obviously it's not catching everything that I need here. How do I visualize? How do I colorize the proximity? Forgot. Not sure how. Visualizers. Can you show it up, please? Okay. So, if I increase this, what about this? It does seem to capture the top part as well, but actually it is not deforming the top part, which means it's not really actually I think I also need to use I need to split the capture part as well. Yeah. Okay, now this works. Okay, so I'll still have some weird problem right here, which I want to fix it because this is going to happen for the head as well. But let's see if I can use the separate head to use these setup. Okay, so this one comes here and this one comes here and this one comes here. Okay, so this is for the head. What's this? Okay, not good. Okay, obviously that's not really good. And that's okay. Okay, so this is not that bad, I guess. So making it separately makes sense, I guess. Yeah. So this is working. Now if I combine these two, it's gonna be any problem here. Now I realize I need to think about the initial angle of the head or initial scale of the head because it's penetrating. Doesn't look correct. Maybe I probably need to control the scale of the head as well. It's supposed to be more smaller initially. But overall, the way it opens up looks correct. I mean, it looks okay. maybe the size of the plant is a bit too big, which I can just control it right here as much as I want, or increase the size of the head. Anyway, overall it looks fine, but yeah, the scaling part. I should control the scaling part. And after that, maybe I can try to place it more procedurally with many plants like these with some random values for rotations or timings. Then maybe I can just finish it. Okay, so scaling is done where? Here. Now it's getting messier. Maybe I should organize this a little bit. So this is for the head part. This is the initial bone. In terms of the crossing for the needles, I guess I should create the left side and right side individually without using mirrors. Okay, but I'll get to that later. First thing first, scaling for the head. So I have the scaling for the whole stuff, one for the body and one for the, both body and head, which is right here. Now I think I should change these values based on whether it's body or not. And I can determine that by using this parameter variable here, attribute here. Okay, so scale. Starting to have tons of frames here. But I'm gonna copy everything here. And this time I'm gonna call this, okay, I'm gonna rename this to this body. Okay, for this one, I'm going to call this F head. Head. Okay. S head. Tons of stuff to change. What was it? F head SC. Okay. And this one is body SC for now. Okay, let's show up new parameters. Okay, so we have okay, this needs to be a new one as well. So head SC is S head SC, E head SC, which well, maybe I can just reuse the same things for this one, probably. Same for this one. Just need to change the frame, when to change the scale. Yeah. Okay. So this one was changing from 1 to 100. Maybe I'll change it to 1 to, I don't know, 60. And then for the head, 60 to 120. And change this value based on whether it's head or not. Part is equal to 0, body SC, otherwise head SC. Okay, it's not working. Or am I missing something? Maybe. So I do have these head frames. This doesn't seem to work. Okay. Or this part. Okay. So maybe something is wrong with the part number value. Let's check. Part 0, 0, 0, okay. Well, it does have 0 or 1, so it should be correct. If the part is equal to 0, then use body SC, otherwise head SC. Doesn't work. Does it work? Doesn't seem to working. That is because this only works on the first primitive, which belongs to the part. So for the second, for the head scale, I think I need to do it on the connection part. That was it. Yeah. So head SC. There you go. Alright, makes sense. No, that's too small. That looks too small. Let's control this. Now in that case, I do need additional informations whether to control the scale for the head. Okay, so let's have that information. And same for this one. Okay, it's a lot of parameters. Now for the ramp, I'll just make it sigmoid-like curve. Okay, and for the head, starting with 0.3. something around here, 0.4. Okay, that's good. Now, initially it should not penetrate, or maybe I should make it really small, and also make the bending, initial bending of these heads a little bit tilted. What was the value that I need to change? So this is for the head angle, and for the initial angle I was using this one right here, and the value is coming from SITNG, just this one. Wait a minute, what's this? No, actually this is not the right value, but I should change the angle right here. So okay, head. Okay, this is why I'm really bad at names. I don't really see what's related to what. This head Y angle. Okay, this is also interesting, but no. S head. No. I body angle. S body angle. No. Connection angle. No. Oh wow. Okay, this one. I probably might need to control the length of the needles. Otherwise, I need to make the angle like these. How would I control the scales for the scale for the needles should be controlled somewhere around here, I guess, using these rig. Yeah. And since it doesn't really cover the needle part, I think I need to extend it to capture the whole shape. Also, the scaling, right? And the scaling should be done somewhere from here, where you can control the size of the needles. I mean, if you want to do it in detail, I guess you should have each needle a rig, but that's too much for me. So to make it simple, I'm gonna introduce some scaling to this somewhere close to the edge of the needle, but the problem is it's on the arc, so probably I should scale it somewhere from here, or change the scaling axis based on the needle position. Oh well, let's make it simple here. Well, let's skip that part and just wanna see the whole part first. So let's say I'm okay with this for now, which is not, but for now. And having to set up the curve, which in this case doesn't look that bad. I mean, this looks a bit too tiny. Might want to control the timing a little bit more. So starting the scale from 30 frame maybe, or you could start from the first frame. But looks getting a bit too obvious. Okay, somewhere around here. It's not bad, not that bad. Okay, and you can modify several parameters to control the final bended shape, which this one looks like the final like head like shape. Looks good. Okay. Oh well. Let's say I'm good with these. One thing I don't like is the direction of the normal, so let's make these reversed. Okay. Now let's try to actually this doesn't look like a heart-like shape anymore. Maybe I want to control the body a little bit more. Yeah, like that. Okay. I haven't really thought about these connections, but which there should be some details for that. Yeah. There. Like that. So it's not really true what I have here. But at least you could feel some bases. Maybe I'm not gonna go too much into detail. I'm just gonna try to go with the setup. Okay, now let's say I have the setup for one plant. Now next step is to have it the multiple number of these plants arrayed. Maybe in omnidirection. Okay, so let's do that. And probably I want to control the timings when each plant's gonna grow by using some random numbers. So I'm gonna use for each. I'm gonna create each one of the plant separately using for loop, and that's just it, using some random values for each. Okay, so for each step I need to control these rigging, this one, and this one, and each of them has to have a unique deformations. So at least these deformation part needs to be inside a loop. Other than that, I don't think you need to place it in the loop. So somewhere around here, covering up like that. So let's try to create a loop like that. Okay, so what will be the first input? I mean, it doesn't need to have an input, I guess. You just need to... So first of all, thinking of an output, this could be an output, right? And you have a loop like that, I mean, it's easier to think when the loop happens, so let's cover it up like that. And I think I can copy this metadata here and place it close to the rig wrangle connected to the second input. Same for this, connected to the second input of the rig wrangle, as well as copy it and place it on the rig wrangle of right here, so that I can refer to this initial information, I mean iterate informations for each loop, and then use that to transform or change the timings of each rigs. Let's start by doing this one. Okay, and going into this rig, let's get the iteration number value here. Okay, which changes per loop, starting from 0 to the end of the loop. And I can use this to first of all rotate this whole angle, whole body with the y-axis. Okay, and use it to transform this local transform. Maybe you can just rotate it on the first point. That's probably what you need to do. So let's create the angle value for that. And well, the value could be just random, but I'll do a golden ratio angle. The y angle is iteration multiplied by radians of 137.5, which is the golden angle, which is being used to simulate like the angle for the seed on sunflowers and lots of plants using these same numbers to make it look natural. Okay, so I'm gonna use this, and I'm gonna create a rotational matrix for this. Rotate well, should start by using identity matrix and rotate dy rot mat with this angle using y-axis. Okay, now that I have it, I can actually, maybe I should just rotate directly here. Rotate the transform with these angles. Okay, as a result you get these whole each plant being rotated 137.5 for each loop for each iterations. Now that looks too artificial. Next thing I would like to change is a kind of a ending angle. Probably it's having these plants finished in the same angle looks too artificial, so let's try to change the finishing angle, which is being controlled by the Okay, this one, the eye body angle, which is this one. So let's try to make this random. Okay, so I have the base value, so let's add some random values to it. So body angle, where are you? Okay, there you go. So I have direct parameters right here. Maybe I should have the angles placed here. And what I want to do is to add some random values to this. So I can say body angle plus random using iteration value, oops, multiplied by some, oh, wait a minute, my keyboard is not working for some reasons. Okay. What was it? Using some random values. Multiply by or using fit function to map between minus 30 to 30 degrees. Maybe that's a lot, but let's see. And finally convert it into radians and see what happens. Okay, not bad. Alright, so angle wise it's not that bad. Timing wise it's weird, so let's try to also control when it's going to be grow. In this case it means to control those frame values, right? Frame based values, which is these values, frames. So I can control, I can add random values to this to control when to start the simulations for each. Okay, so let's create that value. Rand frame. Iterations multiply by multiply by, I don't know, 100 frames. So you have a gap between 0 to 100. And let's just create a simple f value starting with the frame plus rand frame, and then replace this with these. Everything that's using frame. See what happens. Okay, well, I realize I shouldn't add the frame because adding means things are already happening, so you need to make it negative, I think. and make the maximum value of the frame to 1 so that you're always having 1 as a starting point. Alright. Okay. Well, that's that. Let's try to increase numbers. See if it's gonna still work. It's more like a Q. More like a cactus now. Okay, still works. Now there are tons of things you could randomize still. Let's go with the bigger scale. Let's have this just 5 and see what else I need to change at least. So I changed the timing, the base timing. I could also change the sizes or how it's opened per plant, the angle per plant. Yeah, let's try changing the scale next. Okay, so the scale is controlled here, body scale. I think just changing the body scales is fine for this one. So the body scale is controlled where? Here. So I could add or subtract some scale value to this. Maybe adding will be better. So random, again using iterations. Multiply by, I don't know, 0.2. And then you have some variations with the scale, Yep. Let's also change the angle. I did change the initial angle, but the bendness, I guess, it's not. It's a bit too similar to me, I guess. And well, one thing I could do to make this looks a bit more cleaner is to change the angle for the body angle right here. No, the body angle. Oh yeah, the body angle. Maybe I don't really need to make it random for this one, but instead let's say I can raise up the angle per plant by 10 degrees each and see what happens. Not that way. Negative. Well, at least you are going to get some separations between those plants a little bit more evenly, so which doesn't really look randomish anymore, but some cases might look better. Okay, and if I increase this, look more like a bouquet. which looks fun. Doesn't look natural, but yeah, looks fun. Okay, now to the vending. Now I need to know where the bending is being controlled. I think I can do it like that. Okay, so how much it's gonna bend is being controlled here. So maybe this value could also be randomized, but it's not that obvious, I guess. It's not going to be that obvious, is it? Just want to randomize the most effective value. And only that. Okay, so for now I think I do have enough in terms of this wrangle. Now let's go to the shape part. First of all, the body. Maybe I want to control how much it's been bent for each body horizontally, which is being controlled here. So let's try to control that. Okay, so which parameter controls which? So this is the angle. What doesn't? Okay, so this is the starting one. This is the end one. Okay, so maybe this part could be parameter. I mean, what did I wanted to say? This part could be randomized. Yes, and also these frames for sure. And this frames, I think I can share the frame value with these that I have here. Maybe I should share the frame values that I have here. The random values that I have here. So how do I share it? I can just copy the same things, or let's have a seed value. And use that. In here for the multiplications and for the adding, and everything else. No, not for I should make each values different. So okay, so for this one plus 333. Where else? So everywhere I'm using randomness, I am going to use the same seed for the multiplications. So that at least I can control this part, and for this part, if I want to share with the other node, I can also parameterize this part as well. So this be the global seed, and this be the global seed and this is the local seed. And this is the frame offset. Okay, it's getting too much parameters. But I guess those are necessary. Okay, and I am going to copy these and use it here as well. First thing first, I'm getting the iteration just as I did for the other wrangle, and get the seed value, which is going to be the global seed, and some local seed value. Okay, for the seed, I'm gonna link with the value that I have here. Frame seed. Okay, and the random offset also need to be the same thing. Alright, and what's this? E-body. What was this for? Forgot. E-body. What's this? Am I using this anywhere? Nope. I think I just copied something unnecessary. Let's delete it. Okay. So I have the random offset here. Then I can do the same things for this frame. Subtract. And the maximum is 1. Okay. So I can control these bendings, timings. It's the same. Now additionally, I want to change the amount of E angles and S angles, I guess. Some plant might be okay having the curl like these kept. Some part could be really flat, and maybe I can also control these ridge on the center. Okay, so let's control these two angles. First of all, with the eye angle, which is right here. So random iterations seed plus some random number added, and then fit 01. And I can bring this up here, adding additional random values to this with, I don't know, like 30 degrees. Would that change anything? From minus 30 degrees to plus 30 degrees and see what happens. Okay, so I do see some changes. Some plans go like an arc, some plans go like a bend like these. Maybe I wanna make it, I still wanna have it ridges, so from 0 to, yeah, it's a little bit better. Okay, looks good. Okay, now the what was it? What was it I trying to do? I could also control the the angle for this one, but maybe that's not going to be really obvious. So maybe I'll keep it as it is, and instead I think I want to control the thickness, like the width of the plant a bit randomly, which I don't have that information right now because I need to use a scaling for that. I think. Let's try scale for local transform 0.2. Oop. It's not what I wanted. So it's also changing the whole thing, not just the X direction. So let's say I wanna just scale it to the X directions. Okay, that'll do. That's too thin, but maybe if I can randomize these part, might be interesting. So and fit 0.1 point, I don't know, 7 to 1. Okay, so you have a little bit of randomness on the thickness, I mean the width. I mean, you could do the same things for the head now. Okay, so let's go to the head part, bringing up some of the same values, which is somewhere around here. Okay, and I should copy these part, seed. So this is frame seed. This is rand frame offset. Okay. Right. Now, this one is max random frame minus random iterations multiplied by seed. No, I already have it here. So max rand frame 1. Okay. Now, alright, so the frame wise it's fine now. Now next, I'm gonna control maybe the size, like I did for the plant. Maybe in X directions, probably. So, do the same things here. Just like I did here, I have a scale And I have the scale value. Full local transform set SCX 1 1. In this case, I want to make it bigger, I think. Maybe small to big, so maybe 0.7 to 1.5. Okay, not bad. And I also want to control how much it opens. Maybe some of the plants will open up just a few. Some of the plants open up really big. I mean, it does already. How come? How come? Is that because of the scale? Maybe I should use the scale beforehand. No, that's not the reason. This is okay. Why? If I don't have a scale. Okay, so yeah, a scale is controlling the bending, the rotations as well. Okay, let's see why. So okay, so that means it's also changing the length, which means I need to change these weight value. Okay, that's a bit hard to estimate. Right, it's a bit hard. So in that case, I'll just use the result as the random result. Just say it's okay. Although I could still add some randomness to these, how it opens. So, and maybe I can use this scale value to this radian somehow. I don't know if I multiply it, what happens. So it kind of normalized a little bit. Maybe. Better than nothing, I guess. It's hard to tell. It's just the mere changes. Well, let's just have it. And another things that I want to have is just more randomness to this open, how much it opens, which is controlled here. And for the initial angle, I think I can just stay this value as it is, like 75 or something, because it's not really visible. Just want to change the final. Okay, so based on 30, I can plus or subtract some values to this, which is right here. Okay, so I don't know, minus 15 to 15. And into this. Not here, right here. Okay, which gives you a little bit of variations with the openings. The way it scales up is a bit weird. I mean, I want to have more, these parts being more pointy, I guess. Yeah, so it looks a bit weird. Well, I could also make this part where it's controlling the width of the body to be time based, I guess. So currently this is something like that, something like this, but I can, based on the frame value like I have here. So fit 01 F, scale it to 0.1. Is it working? Not sure. It should have. Doesn't look so obvious. Maybe the timings of these head scaling is a bit too slow. Yeah, I need to make those head being scaled up faster, which is done here. This is the head scale part. So from 20 to 90 degree, 90 frames, 80 frames. 70. I guess. It's still penetrating. Wow, it's really hard. I mean, at least I believe I need to remove those needles. Okay, well, if you look from far away, it's not too obvious. Okay, well, basically I think I have added enough randomness to these to make it as a minimum setup, a minimum stuff for the changes. Now, what I want to do is to color these up and try to wrap it up, cleaning up all those parameters that I have, and maybe fix some of the geometries. Since I'm already doing 4 hours, then I think you get tired. I'm getting tired. Okay, let's color this up. Hello, thanks for joining. Okay, so first thing first, let's color this up by based on based on when it has been grown, maybe changing the color based on those plant variables or plant. Let's change the color based on those groups. One color per plant. I mean, I don't want to make it as too drastic, but let's change those colors. I'll change the color based on the iteration of the loop. Which doesn't have to be done here, but well, maybe let's do it here. Shouldn't be a expensive process. Okay, and just going to set some color related value using some random value. So I don't have a seed, but I want to create a global seed value so that I can copy around it, which is being used here. Where? Here. Okay, then I can use that information outside the loop to color the stuff. Okay, so for the point, random from attribute or ram from attribute, use the call and give some gradation between light green to dark green, dark green. Okay, and if we look at the shape here, I think I want to make the mouth part green, I mean red, like that. Looks cool. Okay, so I need to kind of get those part informations from the head, which I should specify that part by creating some group informations when we have somewhere around here. Okay, so we have a needle part, we have the body part. Let's create a group for those first. I'm not sure which one's better, points or primitive. Let's go with primitive for now. Needle. And head. And let's see, after I have remeshed it, what would happen with the group. Okay, not bad. So I have the head and needle being separated. So let's go till end, see if I can still use that group informations for primitive. Okay, I think I can use it. The needle part is more like a light color, so for the head part it's more like red. So let's change this to red to dark red. Make it a little bit lighter for this one. Now since primitive doesn't have a color attribute, it's not using these value here. So maybe I can give another wrangle, which works for primitive. In this case, use different seed. Alright. Let's make this a little bit darker. Okay. And for the needle, let's use the rather close to yellow to green. Colors. And then I'm gonna promote this color to points. Attribute promote from primitive to point, and blur this a little bit, so smooth this out a little bit. Attribute blur. The CD to have some smoothness between these edges. Okay. Right, and then finally connect this here without looking, maybe I should connect this here first. Well. What would I do here? I guess I need to have the groove for the body as well. Alright, so let's have it just like I had it for the head. Let's create a group for the body. And maybe just do the same thing. Instead of using the point color, use the body. So that means I don't really need the point wrangle anymore, which I can connect this somewhere around here. Nope. Here. Okay, that'll do. Looks too vivid to me, but and the back side of the head shouldn't be red, it should be green, so maybe I should after having these mesh, I need to have these, or before bending, where is the original shape? There you go, this one. Before bending, I might want to have the back side as well. So poly extrude. And let's have it in negative directions. Without the side. And also make it reversed. Okay, and I'm going to create a group. One is on the front side. One is on the back side. Merge it. Okay. And okay, something's wrong. I probably needed to make this one's to the positive direction. Yep. Okay. Maybe I should do the same thing for the body so that I can also use in, I don't know, gaming environment. So let's do the same things for the body. Okay, in this case, seems like I need to make this one goes negative. Okay, there you go. Now going back to here, where I am coloring the red part, it needs to be done just on the head and as well as in the front, which this one doesn't work, but I need to create some conditions. I'll just split it. Okay, then merge it. And what happened? Okay, so this case, if it's on the back side, I can use these same colors that I have for the body. Like that. Okay, now it becomes more like a watermelon color. Okay, and the speed is decent, I guess, with these numbers of points. So I remove the point edges. Now this part where it's penetrating a lot is still a bit weird. Let's just increase the initial angle. Guess that will be the only things that I can do with these parameters that I set myself. Where was that? Not this one. Well, I guess I should also control the scale of these needles or the whole plant on X directions. I think that's what I would need to do for this one. I mean, it's okay to have the lengths on Y directions, but not in X directions. Okay, that's for sure. Or maybe making the initial angle like that, which is already bended really much. Well, the basic setup is mostly done. It just what I just need to do is to coordinate those parameters that I have here now. So let's check out the scaling of the head, which is being controlled right here. Currently it's going from 0.2 to well, I think the initial scale is okay with 0.6 or something. Just need to make the length is fine, just need to make these depths being a little bit smaller, which has to be controlled here with these SCX value, which currently I don't introduce the frame base value, but just like I did for the body right here, I think I should do the same with this one. Now, making it 0 might not be a good idea, so 0.1. It's pretty changing pretty weird. Doesn't really look good, does it? Initially, it looks pretty weird. And why is that? And this is why. Why am I using max here? Should use it here. There you go. Okay, now I can make it 0, smaller value. Which doesn't seem to change that much, eh? Or it does. I mean, what if I enter 0 here? Yeah, this is supposed to happen based on 0 value. I mean, based on f value. Okay, I shouldn't just use f as it is, but I need to use the normalized value, which currently I don't have it for the scaling, so let's create that. So need to use a I need to use some sorts of frames value, which in this case, which one should I use? Okay, I can, this is sharing the same value, so I think I can just use this one, S frame and N frame. Okay, 2, 0, and 1. Now I can just use this normalized frame value from. Now 0 is a bit too small, obviously. So let's make the smallest value to something acceptable. Yeah, something like that. Something like that. In that case, I could bend it more. Now I should gather all those parameters in one place, and I'll do that soon. Not this. Not this. Okay. Okay, where is it? Okay, this one. Maybe I can use something like that. Well, still looks a bit weird in terms of the shape. Let's see. Oh, better than before, I guess. Timing when it's going to scale up and open up is not matching that well. So I think I need to share some frame values, which in this case the head is rotating from 0 to 85. In this case it's from 60 to 120, so it's a bit too late. Let's make it 100 and 30. Yeah, getting better. 20. Alright. Not bad. Really looking like a watermelon here. Looks like a watermelon here. Right. Okay, I think as a base setup, I'm pretty much satisfied. So, I'm just going to gather all the parameters up. The things that I have here. And wrap it up. So the base idea is to use KineFX and to combine two KineFX deformations. One is in horizontal directions and one is in vertical directions. Okay, maybe I should use the random value for the bend after all. Yeah, it's much better. That way I can control yeah, that looks like it. Like it. And in the end, if you want to have more like prettier look, you could also use something like ambient, mask by ambient occlusions, create a mask which gives you information like these, and use it to use it with the color you have right now. Multiply the mask and you have some shadings. Just nice to have as a final look. But if you're using things like game engines or stuff, rendering, then I guess you don't really need this step. If you don't have it, then what you'll get is something like that. If you have it, you have a bit more depth in terms of the look. Okay, I think that's pretty much it, right? I myself is pretty satisfied with how it ended up, but let me know how you felt it. If you have any questions, if you know things that I could do more, let me know. I mean, there are things that I should do, something like needles, geometries, and so on. But it's already like I'm spending 4.5 hours. Maybe I'm doing too much. Yeah, and I think you guys are tired here as well. Hi, hello. I've seen your work in your slide. How do you integrate Houdini with products and architectures? And do you keep everything you do within the virtual space, or is it usually product manufacturer? So I have, well, it is possible to transform into a physical object for sure. I did have an experience using it for like physical objects used for 3D printing, CNC machines, laser cuttings, and so on. I mean, it's pretty similar to what you do in CAD drawings. You just need to output the necessary informations from Houdini to those product information for the product in the format they need. If it's an architecture, you do need some precisions, I mean, as product as well. So I haven't used it for structures for the architecture for sure. I mean, those cases I think it's better using more CAD like softwares, which is good at precisions and this precisions of the curves. But when it gets to more organic shapes or facade designs, interior designs, I think you could still use Houdini for the processes. Hope you will make basic Python tutorial like you already did. Many people like myself build better understanding of VEX context of Houdini with those tutorials. Many thanks for Algorithmic design series. Best wishes. Thank you for saying that. It's been a while since I made those series. I think it's been 2 years since then. I think from then I learned a lot while using Houdini for many projects. Maybe I could add some information to those series based on what I learned, but maybe it's a bit elaborated from the basics. So if you're interested. Right. So what was I? Let's organize those parameters. Shall we? Which is on Istanbul. Nice. Welcome. This is in Japan at 3:30 a.m. Time to go to sleep. Okay, so let's gather all the parameters that I have that I can use to control the shape, which in this case I have so many. So let's make it neat. So this is related to the body aspect ratio. Does it changes the shape? Yep. So it changes the aspect ratio of the head and body. It already looks pretty interesting. Doesn't really look like a plant anymore. More like a, what is this? Well, that's the fun part of procedural. Okay, so we have body ratio, body head ratio, bone resolutions, okay, lengths. We didn't really use this. It's not really used for in our case. Mountain. Okay, so let's start by going to the body part. Body. So we have the width of the body. This is related to the heart shape, so just call it heart shape. And I'll call this hot power. Okay. And that's for the shape, and it's automatic. Now this part, should I use the same values here? Maybe. Let's copy this and or maybe not. Not sure. If I use this one, I guess it's fine. Yeah. Okay. Target size. And now this is a bit hard to estimate what's the best size for the remeshing. And if I use the same value as the bone resolution is a bit too much, so let's multiply it by 3. Let's also multiply this as 3 as well. Okay, it's not bad. Or 2. It's hard. 2.5. 2.5. Okay, let's go with these. And extrusions, that's fine. Bend, weight. Okay, so these ramp parameters will change how it curves. I mean, how it rolled. So let's have this. How do I name this? Roll weight ramp. Okay, and so we have a bunch of parameters here. One is initial angle. Initial from the center. S frame. So this is the starting frame. Start frame for the body. This is the end frame. Body start frame. Have you tried making a physically accurate black hole or planet atmosphere with VEX and shaders? Nope. No, I see some people did that on videos, I think, YouTube or anywhere else, maybe Twitter or X, but I haven't tried it myself. I think it, yeah. I saw several people doing it, and yeah, found it really fun. Maybe I want to try it myself as well. Body and frame. Let's change the range. Okay. And this one is E tangle. So this is the angle, right? Body start angle. Body and angle. Alright, so and these values are referenced from somewhere else, so let's just ignore it. That's it. And okay, so I'm gonna move the RAM parameters to the top. Okay, so we have width, heart shape, heart power, initial angle from center, body end angle, and so on. Okay. Do we have anything else? So this is the transformation. Other than that, for the body wise, that's it. Okay. Let's go to the next one, which is head. Okay. First of all, the shape. So we have two parameters, 1 and 2. First one is the width, the head width. Okay, so I need to change this to body width. Body heart shape. Okay, for this one, V was what was it? What was this? B is used for offset. Okay, so head shape offset. Okay, and that's it for the shapes. Two parameters. Now we have, okay, so this segment is also important, which controls the number of needles. Let's call it number of needles. It's more easy to understand. From 1 to 50 or 100. Okay. And so we have the needle length. Okay. And we have, we're not using this bending actually, so we can just skip this. Well, I'll just leave it there. Maybe if you want to use it. In the end, I'm gonna share the file, so if you can play out with it if you're interested. Okay, now let's go to getting those parameters. So the frame, starting frame. So we have several frame values, but everything is being shared. So okay, head start frame, head start frame. Head end frame, head end frame. Okay, and so for the angle we have several stuff. One is for the initial angle and one is for the overall angle. So head initial stat angle, head initial start angle. No, that's not for the initial. This is for the head overall. And this is head overall and angle. And we have head initial start angle, head initial start angle, and head initial and angle, head initial and angle. Okay. Right, so we have these values. What else? I guess that's all for the head. Now go to the overall bending part. How do I call this? Growth. I'm gonna name this to okay. Coming to here, we have a bunch of parameters, which is unorganized. Wow. And I think some of the values, like frame-based values, could be shared between these two. Head-related frames could be shared with the values right here. So maybe I'll do that first. I'll do that first. Okay, so going back to the controller, we have two types of frames, one for the body, one for the frames. And body start frame is 1. So I'm gonna copy this here. Go to where we have overall growth, where we're also setting the frame informations. Oops, just copied it. Copy this, paste it here. Okay, same for these. Okay, doing the same for the head. Going to copy the head frame start. And then using it to right here, I think. I mean, you could use the separate one, but to make it simpler, maybe I'll just share the same value. Oops. Let's check the result, if it looks weird or not. These ambient occlusions a bit expensive, so I'm gonna disable it for now. Yeah, not bad. Okay, so looks good. Next, we have the body angle, yeah, and the body, the starting and the end body angle. So, how do I call this? Body growth angle. It's bending in, wow. We do have body and head again here, so I could still place it right here for the body, but it's a different purpose, so let's have it separated. Maybe I can call this body growth. Okay, so body body, so it's bending, it's still a bending but in different directions, and one rotates horizontally, one rotates vertically. What's the easiest way to call this? Well, it's not a growth. Okay, I'm gonna just call it as an axis. So the first one, we had body start angle, body start angle, body end angle, but I'm gonna change this to body start. This is y-axis angle, so I'm gonna call it y angle. Okay, this one as well. Y, Y. And this one is X angle. So body, start, X angle. You can see I'm really bad at names. Okay, So next, eye body angle. So this is the initial angles for the body. Do we have that kind of stuff? Yeah, we do. So might want to change this as well. The body initial y angle, or initial y angle, and this one is body initial x angle. Okay, now this one connection angle. Okay, which is similar to head angle, so I'll call this a head initial angle, x angle. And for this one, let's separate it. Head growth. Okay, going to the next one. So we have head angle, which is wait a minute, am I using this value here? Maybe not. It's being replaced with these one, maybe. I'll check it out. So this one is head start x angle, head start x angle, head start head end x angle, head end x angle. So we have a similar things like here. So I'm gonna change this to head start y angle, head start y angle, okay, and this one as well. Head initial start and y start angle, okay. Now let's check if I am using this value here, con angle. Probably not. Yeah, it's gone. So I need to remove this. Okay, and also errors. That's because I have this one, right? Okay. So instead I have these two. One is head initial start x angle, head initial start x angle, head initial end x angle, head initial and x angle. Okay. Wow, tons of parameters. So this is a body ramp which is related to what? Forgot. body ramp is related to the angle. So this one, body x ang ramp. Guess that's too much. And head, which is related to these. Head x angle ramp. Head x angle ramp. I love these live stream. Thanks for saying that. Please never stop. This live stream are a treasure for intermediate technical artists. Thank you for saying that. Appreciate it. Thank you. Diagrams can be source of inspirations when gives names, but in this complexity, I think even a pathologist will struggle. I guess so. Okay, so we have a head ramp, con ramp. This is the initial for the head. So head initial x angle ramp. Head initial x angle ramp. Okay. So this is the frame for the what was this for again? This is C frame. This is for the body. I think I can just share the same value what I have here, so I'm just gonna copy this parameter, paste it here, copy this here, paste it here. Okay, SC ramp, so this is for the scaling ramp, okay, which is related to the body, I guess, or the total scaling. Well, I can just say spot for the body. So let's place it right here. Body scale ramp. Okay. And we have the minimum scale. Body min scale. And the maximum scale. Actually, this is end scale, I guess. This is the start scale. And this is the... Okay, this is based on the head, so which goes to the bottom part. Which I think I could still share the same values what I have for the head frame. So I can kind of copy this one here and paste it here. Copy this one here, paste it here. Right. And do we have this? Okay, so I'm gonna bring this here, which is a head scale ramp. Head scale ramp. Okay, getting closer to the end. This one and this one. So what was it? So this is head start scale, head start scale. this one is head end scale, head end scale. Okay, so for the seed, this is the global one, so I'm gonna put it into top here. Frame seed, this could also be. So I'm gonna name this to global seed. And for this one, frame seed. Okay, and round, so this could also be global, so random frame offset. Alright. Given, now I do have several more values that I could randomize, such as these random values for each angles and scales. Maybe I should parameterize this. So, I mean, it's better if I have just one value, so in body random angle offset. And I could use this here. Okay. Got it, getting an error here. What did I do wrong? Maybe I deleted something. I think I did something wrong. Let's undo it. Okay. Going back to where I was adding randomness. So using random, no, just getting a value here. Okay, and I can bring this value to the body, which is related to the initial angle, so somewhere here. Body initial random initial angle rand offset. Okay. What else? So we have okay, I already have that. Anything else? This one is the scaling offset value, so maximum scaling for the body. Right. Which is 0.2. So that comes somewhere around in here. Body scale random offset. Okay. That's it for this one, I think. Yep. And it's fine for these one. In terms of the final like colors, I could parameterize, but that's not really important. I might want to be able to switch between the shaded version or an unshaded version. Unshaded is much cost effective because it doesn't need to calculate the ambient occlusions, but it's prettier if you have occlusions for sure. Oops. Yeah. So maybe I can have this value as a parameter. Or okay. That's it, is it? Well, I do have these random related values for the scale for the head and scale for the body, so let's have that as well. I think I just need to parameterize this one for this. Min body scale. Okay. Which comes to related to the shapes. Goes somewhere around here. Body min width scale. Which could come just after width. Yep. Same for the head. I think I have similar values, which is here. I think I can make this to 1 to make it simple and just only change these values, since I can still change the width of the head with other values. Alright. Getting close to having all the parameters. Alright. Okay. Well, there's another one here. This is related to the opening, how much it opens the head, the part. Let's have that as well. And offset. Okay, let's bring that to this one as well. goes to, where should I do that? Head. It's related to the angle, so somewhere around here. Up. Okay. Head. Ang. Y. Rand offset. Head. Ang. Y. Rand offset. From, I don't know, 0 to 60 degrees. Okay, and I think I have promoted all the parameters that I want to control in order to change the shape. Maybe I might also want to control how much plants to iterate as a global parameter. And that's pretty much it, I think. Okay. Let's also change the range to maximum 200. See what would happen if I have so many. So I have so many parameters here. Each one does something. Let's look at these from top to bottom. First of all, the aspect ratio changes the shape, size, aspect ratio of the head between the body. The bone resolutions is the resolutions of whole shape. If it's higher, it's more low res. It's low cost to simulate. Number of plants. Nice. Number of whole plants, obviously. That's too much. Let's make it 15 for now. Okay, and the frames, see, these are the randomness. Frame seed only works on the animation, so it's not really easy to see the results. The random frame offset, let's change the range to 1000. Now this changes how each plants grow in which timing, changes the randomness of the timing when it's gonna grow. Right? Okay, looks good. And the ambient occlusion is switch toggle. I want to make it as a toggle. Either on and off to show the shades. Okay. The roll weight ramp is to control the rolling effect. When to finish the rolling. I think it's like these better. Yeah. Body width. Okay. body min width scale. So this is the randomness. Some could be really thin, some could be really thick. Body heart shape. This is to control the ending part of this, the connection part, the shape of these connection part. If you increase this, you get more like a heart-like shape. So that's what you can get. And the body is also related to the heart shape. The body initial Y angle. This controls how much it bends on the center. Okay, it gets better on negative. Just a little bit of negativeness. Okay, and the body frame start. So this is to control where you start growing the, when are you going to start growing the body part and when to finish it. Okay, if you want to use more times to grow, then you can increase the body and frame. Or make it faster to make it small value. Okay. Body start Y angle. So this is the angle value for the body, which starts means the initial direction. I mean the rolls. This is used for the roll angle. Like that. Okay, so initially it's like 260. And ended up using this end Y angle. Okay, comes to the next comes to the head part. You have the width. Okay, and the head minimum scale width, which controls the the randomness. Some could be small, some could be bigger. It's not this one. I'll keep it to 0.7. Okay, then we have a head shape offset. This is also related to the shape itself to create more like a shell-like shape. So having width and offset, you can control the overall size of the head. The number of needles, pretty obvious. Not so clean here. I think it's also due to the resolutions we have here. Phone resolutions. Yeah. So if the resolution is low, then you should have small number of needles, I guess. Or just change how the needle is being created from scratch. Maybe that's better. The way I'm creating the needle is not so neat, not so realistic, so I think there are some space to update this. Okay, the needle length. Yeah. Let me just make the resolution is a bit more smaller. Okay. And the head start frame, this is okay, the when to start the animations, and I think I need to change the ranges. Okay, and head start Y angle, this is the angle, initial angle for the head. Which is somewhere in this positions. So I'll keep it to 10. More important value is the end angle, which defines how much it opens in the end. And you have a random offset, control the randomness of the final openness. You have a initial Y start angle. What's this? This also controls. Okay, so this controls the overall angle of the plant, and this controls the curvedness of the head. So this is more important. This is more dynamically easy to see the result. Right. Actually, this angle random offset, maybe this is for the initial. Let me just check that. So I have the randomness, and yeah, actually this random offset was for the initial angle, so I named it wrong. This has to come here. Okay. And yeah. And the growth. This is the angle. I mean, this is the angle for this bending on x-axis, which is, yeah, very dynamic. And how it related to the frames, how it grows based on the frames, and initial angle. This also controls the initial angles. I'm gonna stay to 30 something. Body initial angle randomness. You can change the randomness. If it's 0, it's all aligned in the same angle, which looks not natural. So having a little bit of randomness makes sense, I think. Yeah, maybe that's too much. Yeah, something like that. And the scale differences. This is being animated, I guess. So initially, the scale. No, this is for the animation, not for the randomness. So initially, the scale is small for the head, getting a little bit bigger later. So it doesn't have to be that small. Could be 0.7. Okay, then this is for that rump. And we have a random offset in terms of the whole scale of the body. Yep. And what else? Head, X angle. So how much it bends in total. And we have so this value controls how much it bends in this directions, and it still penetrates. I think I need to do something about it. Maybe not at this live stream, but maybe later. I mean, to deal with it, I think it needs to rely on the exact shape, which in this case it has its own like main bones on the center, which I haven't created, and which connects the leaf part and the head part, the body part and the head part. So I guess having this value, having this geometry as the connection, as the third geometry make sense, but I would not gonna do that. Okay, so I'll just leave it as like this, being penetrated. Looks not too natural to me. At least let's just open the head a little bit initially, so that might looks a little bit better. Guess not this one, but the yeah, like this one. Well, initially I think you also don't have needles, so that's one thing you should fix. Wow, so many things to do. Okay, that's that. Not going too deep into this. Okay, and what else? We have a head start scale, so this is scale value for the animated animations. And that's it. That is it. So that is going to create one of the simulations for a so-called Venus Flytrap, which I found it fascinated. How its growth, how it grows, how it shapes, how it reacts to the flies or any other insects. Yeah, this is it. And I guess it's time to finish the live stream at this point. I mean, there are several things that I wanted to do, well, especially for these needles maybe. But times is like 4:30 a.m. right now and getting tired. Think I should stop at some point. So these are the needle part. Right. And it's been deformed using this one. So mixing two deformations gives you a lot of defects on the needle part, which is fine, but the shape itself, I think I want to make it more thinner. Okay, let's just make it thinner and I'll end this. Okay, so where is that I made the needles? Oh, okay, so I have these. Let's see. First of all, let's see if I can use a poly extrude to these to a individual elements, not to the distance, but maybe insert. Nope. Not really. Yeah, if I could just choose a specific edge, guess I could do that. Well, I'll be able to. Poly extrude should be on the line, not the skin surface. To make the needle, I mean, okay. Let me try that. So, if I made this to individuals, and probably I need to set a normal informations to each of the point primitives, I guess. So let's see if I make things unique. Can we still let me change to this one and create a orientation along curve. Oops, not this one. Orientation along curve, which will give you a tangent and up. Well, I don't want to use a tangent, I guess. What's happening here? I don't want to use a tangent, but instead I want to use... I'm not sure if this is the up direction that I want to use. Close, but okay. Well, at least if I have a tangent, I can remake the normal. So the normal should be cross product between the normal and Z. Okay. Now the end of the poly extrusion, mega divisions. Thought I was able to control the scale on the end. Not sure. It's interesting, but not what I want. Transform extruded point, scale to 0, extruded front. Extruded front. Ah, this one. Thank you. There you go, thank you. That works. Awesome. Now, I think... let me see if I can... if each point has some information that I could use. Wow. Probably what I want to have is the point attributes on each column, defining whether it's close to the starting point or not. Or an integer value showing the division number. I might not have it, so hopefully I could promote it some. Local attributes, nope. Spine control. Not sure. Well, maybe I can just calculate the distance from each point to the original curve, because it's all perpendicular, so you can just project it, and that will be the value you can use. Yeah, I guess I'll do that. Right. So now I have it. I can now then project to this one. Okay, and the maximum distance will be equal to this distance here, so which should be the needle length that I have here. So I'll just use it right here, and also have it as a parameter here. And normalize it and use it for scaling these values. Okay. I'm gonna use a run parameter to control the scaling. Now, actually, in order to do that, I kind of need to know the center of the scaling for each point. Which in this case, how would I get that? Oh well, I can get it by getting additional informations out of XYZ distance, And this primitive stands for the number of primitive, and I can get the center of this primitive. Right, and this could be, and the actual center for the scaling will be center a plus, now in this case I might want to get the projected point position on the curve. Okay, now I can say at p minus p pos normalize by the distance, multiply by distance, could be the center somewhere around here, hopefully. And using this to scale, see if this gonna work. First of all, subtract with the center value, multiply by t, and let's see, center. Some works, some not. Okay. Which means, yeah, some of the well, one thing I should not do is to scale the initial points, so I have to skip if the points on if the points on the distance is close to 0. So this should only be done if this distance is larger than 0. Okay, alright. Weird, but working. So now, actually, in this case, I might not need to transform extruded front. Well, I do, still do it. What I need to do is to control the ramp shape. B-spline, B-spline. So this is the original shape. And now you can I don't know, do like that. Well, I don't know what to say. This is not sure if this is good or not. Well, better than just a triangle, I guess. Yeah, this is better than this one for sure. Okay, now I'm gonna keep the original. I'm gonna call this needle 2. Switch it between original and the new one. See what happens in the end. Well, I think I need to flip it, maybe. Right. I think I still need to do something for the deformations. I mean, I think it's about the resolutions. If I make the resolutions really high. gonna start fixing it. Although that's also going to increase the tons of meshes here, so maybe only for the needles might need to increase it. But overall, I think it becomes better. Yeah, for sure. For sure. Now, when we are doing the, well, what? Do I really need this reverse? Yeah. Just gonna recreate an old. Okay, for this one, I would need more resolutions on the needle side. Right, so what I could do, maybe I should just remesh it separately, the body part, I mean the head part, and the needle part separately. For this one, should also be related to these bone resolutions. Which previously was something like multiply by 2, but for this one I could actually multiply by 0.5 or 0.75 and combine it with merge. Now I have some problem here which doesn't share the same edge anymore, so I'm not sure if it's gonna work. Let's see. And this comes here. Let's see what happens. Eesh. Well, morphing is working, but I still need more res. Oh, maybe not. Maybe this is not the problem. This wasn't the problem, so yeah, this is not also a problem. And let's see, probably this part. Okay. Okay, so beforehand, was it okay? Yeah, and done. What if I increase the res? Right. So that was fine. The problem is here. Ugh. Let's check it out. So this is it, where it's capturing it. Seems like I don't have enough lengths for the bending, and that's true. That is true because I only have these lengths here. So it's not really capturing full. Right. Maybe that's one thing I need to fix. Well, it's not clean at all, is it? But if I increase the influences, it becomes better. Okay, so I'm gonna increase the maximum influence to 30, which will clean it up, but it also changes the whole shape a little bit. I mean, a lot. So might need to control that. In those cases, maybe I can still use the low res version. Yeah, okay, it's good. That way I don't really need to have two remeshes. So I can connect this here, here, like that. There you go. Nice. Much better. Much better. And if so, then should I use the same process here? Make this maximum influence to 30? Maybe. And should I do it for this one as well? Maybe. But it removes the details. I'll keep it to 2 for this one, because doesn't have much problem. Also for this one, makes it to 2. Having these bending, the overall bending having 30 might be okay. Might makes more sense. Let's check the final. Nice. Nice needles. In the end. Okay. I think I'm satisfied with it. The needle skinning should be the same throughout each needles. If needle 0 is skinned to bone 0, then the entire needle should be skinned to. At the moment, different parts of a needle can be skinned to different bones, causing improper deformation. Okay. Needle should have the same color from the bottom to the tip when you look at the joint. I see. Makes sense. Thanks for the informations. I think I'll take it as another solutions to solve this. For this one, seems like just changing these one fixed it, but the way I made it, the needle was, yeah, something out, probably. Okay, well, thank you for all the informations. I think it becomes much better in the end in terms of the shape. Really like it. It's a bit weird having some space between the head and the planned. Why is this happening? Doesn't it's not supposed to happen like that, but let's see. Is it because I separated it? So I have these shape and I have these shape right here. It's already been separated. Well, shows a small part of the positions. Now, if I look at how the bend works, let's see. Okay, so I guess it's a problem with the max influences. Maybe I would still want to use 2 to have more influence. So in those cases, I think I need to follow your steps. So the needle skinning should be the same throughout each needle. Needle is skinned. Skin tickles. At the moment, different parts of the needle can. So I have these shapes, and it's been different parts of the needle can be skinned to different bones, causing proper deformation. Needle should have the color from the bottom to the tip. I see. I see. Well, which this one doesn't. Obviously. Okay. That's the problem. Let's see if I can change it personally. I mean, customly, looking at the information, getting it, checking information right here. So what do I get as an addition? I have a bone capture. I see. Bone capture weight. Bone capture ring. So these must be those values. Okay. And each point is related to the point number on the bone. In this case, coming from the second output. So this one. Right. I see. I see that now. Okay, so maybe Instead of using just a line, maybe I can transform this curve to align with this curve here. Which is done somewhere around here. Let's go back to where we were changing the shape. Okay. Okay. Now, maybe I can set some information to the tip of the curve somewhere. I'm making a needle. Okay. Okay, and if the distance max d is close to each other, then set point group. Let's check it out. Do we have this tip? Yeah, it's being colored red. I think we have it. Now let's go to here. Do we still have it? Nope, it's gone. Maybe I need to check the end and back to here. Nope, still not. This okay, it's already gone here because of the remeshing, I guess. Now this doesn't also keep it. Okay. Okay, well this does keep it. Okay, fusing, delete it somehow. Why'd you do that? Oh, okay. So this was a bit too small. Okay. I can go back to where it controls the how's this? Okay. And does this keep the tip? Okay. having come here. Let's see if I get the tip. Okay. Now let's try to get the tip points. Right. Now. Now. Let me check. So this one gives you the bone capture information. Right. And not really sure what this is. 0 and 1. So you have two weights related to 2 points. Good. Just wondering if it's gonna work if I deform the curve like an arc shape related to this shape here. If that's gonna work. Not sure, but let's see. So probably not, because I have both ways. I think I shouldn't do the mirror at this point and see what happens. Maybe it doesn't work. Nah. Nope. What I would do is to have an integer attributes that identifies each needles before skinning. Then after join capture proximity, use a capture attribute unpack, and in a wrangle set each point in the needles to be the same skinning as its root or tip. This it seem to be going for have an integer attribute that identify each needles before using connectivity. Then after join capture proximity, use a capture attribute unpack and wrangle set each point in a needle to the same skin as root or tips as you've seen. So this one has its own name. I haven't used the no goal capture attribute unpack. Not sure how to use this one. Let me see. What does it gives you? Bone capture data. Bone capture index. Let's see. So this defines which points on the bones is being used, I guess. Probably. Maybe. Bone capture data. 1 and 0, 1 and 0, 1 and 0. What's that means? Is it, does it mean in between 0 and 1? Not sure if that's the meaning. The weight is pretty much close to 0.5 for everything. Gives you the bone IDs and how much it affects the point. Ah, okay. Okay, I think I start to get it. Right, let's see if I can handle it. So probably it will be better if I have same number of points on the bones and the needles, which I don't know if I have it right now. Maybe not. I probably have more points on the needle side. That's one problem. Okay. Well, I guess for that reason I need to use the weight, probably. Okay. So the needles. Okay, let me try to set the IDs for each needles first, which I should do somewhere around here. Let's see if I can add some IDs to here. Based on the primitive numbers and see if it can be Okay, so I have these IDs. Then I think I should also create an ID for the other part. Just gonna call it -1. Now, if you fuse it, not sure about the connections, but it still keeps you these ETs. Let's check. Okay. Now, after being captured, let's try to or maybe I think I also want to color this gradually using the head part as well, not just the needles part. So how would I do that? I think I have the skin geometry, which I think I can use to color these as well. For each needles I can color using the same ID for the needle that I have here. Right. So how did I make an ED? So how do I detect it? What's the best way to detect it? I mean, maybe I can just sort it from top to bottom. That doesn't sound neat at all. Oops. Well, after it's been merged, I think it's better if I set an ID here, not the negative value. Oh well. But after all, I'm just gonna use remesh later, so it is going to be changed either way. Just go back here and see what can be done. set the weights to 100, which will force skinning to a single bone. Then use capture attribute pack to get the actual skinning info back. You can set the weights to 100. Okay, let me test that. So we have a weight. Okay, so bone capture data. I mean, this is the weight, right? Let's see. This is bone capture data. Set array. Oops. Oh, now it's crashed. Okay. Let's see if I can find the okay. Think it's crashed. Guy force quit it. Well, hopefully I can get it back. Houdini got tired. Yeah. I assume that. And this is not the one. Okay. This one. Yep. Okay. Okay, so just change the weight and capture attribute pack. See what happens. So without having it. Ah, okay. I see. Okay. Okay, so I see that using the attributes here would gives you an option to control those weights and which points to be controlled by which bones. Alright, thank you for the informations. I'll try it, and hopefully by succeeding it I can go sleep well. Alright, so for these, at least I need to know how many points that I have, I think. So, and at this point I do have an ID for each tips, so and those IDs comes, I mean, let's also get the maximum number of IDs. I mean, I don't think I'm doing an efficient way. I think you know more. But let me try this thing if that could work. Okay, so I have just promoted the ID to the maximum number of IDs to the detail. Nope. Oh yeah, forgot to. Okay, so that's 27, and I want to know if it's on in which direction is it. So it's pretty much the primitive number, and that is going from bottom to top. Okay. And what about these? Is it the same? Yeah. Right. And then, so we have 22 points. Do we have that info? Yeah. So maximum is 21, so seems to be these are the point numbers. Okay. In that case, say I could refer to these points and first of all, get a current ID, get the maximum ID. What was the name? ID max. Okay, and convert it and normalize it first. Then convert it into a point number. First of all, getting the number of points from the second inputs. Then get PT number 1, which is the floor of T multiplied by num PT. And another one is PTN2, which is the ceiling of T multiplied by number PT. Okay, and I want to use these two numbers as the value for what? Bone capture index. So let's try doing that. So a long capture index is equal to set, and I want to create a conditions if the ID is more than or equal to 0, meaning I'm gonna skip the one that's not needle, and then btn1 and btn2. This is array. Okay. Now, let's see. Then packet. See what happens. Oh. Well, but looks cleaner. I mean, there are defections here and there, but things are getting better. Few things are getting better. Think I need to do some fixes here and there. So let's see where I should fix it. First thing first. There are some points that I'm using same indexes right here. Probably these need to be 0 and 1, I guess. So I don't know, but that's my assumption. So for the minimum, no, I guess for the this is gonna use maximum 1, and it's also using 21s as maximum. That's not correct because yeah, actually this has to be -1. And for these, I think maybe that was just the reason why it didn't work. Let's try this 0 and see if it's gonna work. Okay. Well, not on this side. What's this? Okay, so probably I also need to do something for the ones on the not just the needle, but on these, how do I say, the body side. Or no, maybe probably on the connection between the needles and the body. That's where something weird is happening. Let's show up the edges. But this is pretty interesting. Didn't know how this works like this. Okay. So this totally changes the needle positions. No, actually the body position is changing somehow. Okay. So I guess I need to fix that. And this condition isn't doing well. maybe. Just go back. I should just go back and set some IDs for these geometries as well. Somehow. Okay. Alright. So how many primitives do I have? 28, which is not equal to the number, which is equal to primitive edges. How's that? Okay, if that's so, then I'll just assume that this is positioned from bottom to top. Yeah. So I think I can just use the primitive number of this as an ID as it is. Alright, if that's the case. If that's the case, I shouldn't set an attribute to the point yet. I should do that after remeshing it. So, well, I should probably just remesh one by one. And for this one, after I did the remesh, I mean, that's the best way. First of all, I could give an ID to the primitive, just the primitive number itself. Now I want to promote this to a endpoints, but after I have done the remesh, what happens to the primitive IDs? Does it keeps its values? Problem is, it's not going to be smooth as I want to. Let's see. Kind of I want to automatically interpolate the value when doing remesh, so I should probably use it for points. Okay, I'm going to make the points unique so that each geometry will be remeshed individually. That way I could use just promote the IDs. Guess I also need to find a way to calculate the weight, but let's not do this for tonight. So remeshed it, and do we have an ID here and there? Okay, and if I fuse it, one of the ID is gonna be used, I assume. Let's check. Going back here. And I don't really need this conditioned anymore. Oop. Well, actually I did need it. Huh. This makes me confused. Why? Oh well. If I have this condition, it seems to work. So I guess that's fine. I mean, probably doing the remesh and fusing on the later process made the ID messed up on the D side, but at least it's preserved one on the corner, so that's why it's preserving the geometry. At least seems to work till here. Does it go to the end? And the where's the half? One half of the. Okay, so I wasn't able to. Actually, I am able to mirror it. Yeah. Okay. What? Okay. Alright. Alright. Finally made it. Thank you, thank you, Alan, for all the infos. That was really precious. I think I learned a lot from this. Yeah. Awesome. Thank you very much. And that's a good time to end the live stream, I guess, for tonight. Oh, thank you for sticking, and well, I really enjoyed this live stream today. I'm gonna upload the files as soon as I finish this live and paste the link to the description page of this YouTube live stream so you can download it and try it out. I'm also gonna paste the link to the Patreon page, which you can just look at it for free. So please check it out later. Okay, thank you very much for all the comments. Hi Tema, thank you so much for all your videos. Thank you very much, everybody. Appreciate all the comments. And let's just check the final animation and I will end the live stream. Yeah, the needle looks much neat, much better. Cool. And that's it for tonight. Thank you and good night. It's already in the morning. It's like already 6 a.m. soon, but I really enjoyed it. Okay, night, and probably see you next week. Thank you.